Hey, what's going on everybody? It's Caleb. Welcome to your C programming crash course. This is going to give you everything you need from writing your very first program all the way up to memory management, structs, and pointers, and everything in between. Now I did break it up into chapters and sections so you can get the timestamps for those in the description below. If you enjoy the content, please be sure to subscribe and leave some comments below. Let me know what you think and what you'd like to build with C programming. Now, right before we jump in, I want to give a special thank you to our sponsor that's doing a lot to change the world using technology, Call for Code. Call for Code is a global challenge for developers to create open source technology to help in times of natural disaster. Created by the David Clark Cause with founding partner IBM, Call for Code is bringing hundreds of thousands of developers together to build solutions using technologies such as blockchain, AI, and IoT. With winning projects receiving cash prizes, project support from the Linux Foundation, and more. Natural disasters are among the world's greatest challenges, with 2.5 billion people directly affected since 2000, and you have the power to help. Will you answer the call? Learn more by following the link in the description. Alright, so let's get into C programming. Welcome everybody to your C programming crash course. My name is Caleb, and let me tell you, I am super excited to go through this course with you guys. I think there's going to be lots of valuable information, and it's definitely not going to be a waste of your time, so thank you for giving me the chance to teach you guys C programming. Let's try to make C programming fun and exciting. Some of the things we're going to be covering in this course are these things down here, and I'm going to basically be doing this in a crash course manner, so I'm going to go over a topic and basically teach you what you need to know, and then there will be a syntax reference guide for each of the sections that you can use for future projects. I'm not going to waste your time with fluff, but I'm also not going to just teach you something really quick and not really explain it. My goal is to explain it, but not overdo it and get to the point right away. And hopefully by the end of this course, you have lots of practical examples that you can use for future projects. Or at least the bare minimum, I hope you guys can understand all of these concepts and understand the syntax to make things work. So we're going to start with the basics of how to compile, how to make a C program run, and then we're going to quickly get up into arrays and strings, move on to functions and creating our own functions, and then we're going to go into some of the more intermediate and advanced topics of structs, pointers, and memory management. It's going to be pretty super awesome, and I'm really excited, in case you guys can't tell. So the very first thing you need to do is you need to get a text editor or a code editor. I'm using Visual Studio Code. I think it works great, but you're free to use whatever you want. You can look up, and you can find people talking about which ones are best. The next thing you're going to need is a compiler. Now, inside of Visual Studio Code, you can actually access the terminal, which is where I'm going to be doing all of our compilation stuff. But if you don't have Visual Studio Code, you can just open the normal terminal app by going to your apps. Now, this is being ran on a Mac. Things are going to be minorly different between Windows and Linux. Mainly different if you're using Windows, but if you're on Linux, it's going to be very, very similar. If you're on Windows, you might want to look up how to get C programming going in Windows, and then once you got that down, come back and start applying these principles taught in this course. But basically, what we're going to do is we're going to type GCC, and that is the command and the program used to compile code. Now, when you get this no input files, that's a good thing. That means GCC is installed. If you type in GCC and nothing happens, or you get a warning, or you get basically instructions on how to download it, you're going to want to follow those in order to get GCC installed. Very simple. You guys shouldn't have any issues, but I'm sure if you do, you can easily find solutions online to the problems. Once you have GCC installed, you are good to go, and you can move on to the next video where we're going to be talking about some of the main Linux commands that are good to know for this course. Now, if you want some more of the background of C, I'm going to be talking about some of these key things that I put in this note here, and basically just trying to explain C programming at a more higher conceptual level so you understand the upcoming content. The very first thing is that C is a compiled language. That means you take your code and you compile it down to an executable. That means all of the syntax in your code has to be legal. It gets parsed to see if your code is a legal code, and if it's not, then it's not going to be able to compile, and you'll get a compilation error. C is one of the oldest programming languages, and it's actually still actively used today. it inspired many of the more modern languages of C++, C#, Java, and so forth. Now, you may be more familiar with some of these languages because of school, or maybe you're more familiar with Python, and a lot of these are object-oriented. Well, C programming is not object-oriented. The other thing is that C is statically typed. That means whenever you create a variable and you're going to work with some data, you have to choose a data type at compile time. And that variable is basically tied to only storing that type of data. And the thing you guys need to know is that C is not forgiving. What that means is that it's very easy to make mistakes, and half the time the compiler is not going to say anything, or you're going to get some crazy error like segmentation fault, and you're not going to have any idea what to do. So this is something you're going to have to get used to, and I'm going to try and give you some good tips throughout this video series. Next thing I wanted to talk about is that C is very hard to pick up. At least it was for me, but it's definitely not too hard once you get the hang of it. It just takes a little bit more time to wrap your brain around some of the potential issues and challenges that usually you don't have to worry about in languages like Java. For example, once you get into strings, well, strings are a huge pain in the butt in C, and you'll see why when we get there, but it's definitely not to the point where it's too hard, and if you're struggling, I just want to encourage you to keep at it, and you will get it, especially once you have the syntax reference guide, because you can literally just copy and paste a lot of those examples and fill in some different variables that you're working with rather than using mine. So other than that, C is basically very similar to the modern languages. It has all of these capabilities, which many of the modern languages have all of these. So it's not going to be radically different, and you're going to see a lot of syntax similarities between C and some of these other languages like C++ and so forth. So with that, be sure to check out the next video. I promise you guys it's going to be awesome, and I really hope you guys aren't disappointed. As you go through this, if there's anything you think is confusing, please be sure to let me know, and I'll consider it for future iterations of this course or particular videos. So thank you guys, and I'll see you in the next video. Hey yo, welcome back everybody. This is going to give you what you need to start working in the terminal on Linux or Mac. Now if you're on Windows, I'm sorry. But basically we're going to learn how to do anything you could do clicking on the Finder or in a folder structure. We're going to learn how to do that in the terminal. And it's going to be the same on Mac and on Linux because Mac is actually a Unix operating system. So very similar in nature. So all the commands are going to work on both of those. So the first thing you might want to do is basically figure out where you are in the file structure. So basically try to think of the terminal as a command-based way to navigate folders, also known as directories, and copy things and do everything like that. So basically anything you could do with the mouse, you should be able to do in the terminal. So the first thing, we can do pwd, and that's going to give us the absolute path to where we are. This basically defines the folder structure. So if you were clicking, you would go into users, you would select Caleb, go to the desktop, and then open the C folder. The technical name is directory, so I'll try not to say folder too much, but you can use the terms interchangeably. So when you get into this folder, the first thing you might want to do is actually see what's in it. So you can use ls for list. And this is going to basically just spit out all of the files in this folder, and these are the things we're going to go through in this course. Now, obviously, you're not going to have all of these unless you downloaded the source code. In that case, you may have a similar structure to this. Now, there's something in the terminal known as a flag, and that's when you put a hyphen and a letter. So, for example, ls-l, that's list long. That's going to give a long version of basically the same thing, but now we have permissions, some file sizes, and dates, and a bunch of other crap. Another one is ls-a, which is all, and this is going to include a little bit more, specifically this dot and these double dots. The single dot refers to the current directory. So if we need to reference the current directory, that's how we do it. If we need to reference the parent directory one folder up, then we use the double dot. So for example, if we do pwd, desktop would be ... right now, and that's relative. So if we went to a different directory, the parent is always going to be relative to where we are. So it's not like these double dots is permanently referencing desktop, just in this case. So what you can actually do is you can combine these flags. So for example, you can do ls-la, and that's going to do both of them. So now it's going to give the long version, and it's going to include these two here. Now that A, the only thing that it really does is it will include all files. So if you have hidden files that normally don't show up when you're going through the folders using a Finder window, well, the A is going to expose those here. Now, if you want to change directories, there's a command cd. And just to show you how you can reference the parent, I could go cd ... and that's going to move up to the desktop. So now, when I get our path, we're just in desktop. So that was an example of giving a relative path in the sense that the location that it goes to depends on where we are. You could also do a complete path or an absolute path like this. cd -users -Caleb or slash, yeah, that would not be a hyphen, that would be a / desktop /c. So those are some of the basics. Now, there is another shortcut you guys should probably know, and that is this tilde. That always references the home directory, and the home directory is the folder you're in when you open the terminal. So that's going to be, I'll just show you, cd home. That's going to take me to my user folder, so Caleb. You can also change directories using relative paths more than just up a parent. So for example, if I go back to that C folder, let's go into the C folder there, I could say cd parent, and what that's going to do is that's going to go up to the desktop, up to Caleb, and then put another slash, and if you hit tab twice, it's going to list the possibilities, and we could go into Docker, for example. And now we're in a Docker folder. So basically, we were able to go up 2 folders and then look at the contents to choose a new folder in that one to change directory to. Basically, you just have to understand that you can do more complex change directories. It doesn't have to be the same simple ones all of the time. Moving on to some other commands, there's an important one you might want to know. You can use clear to clear the window. Touch, and this is going to create a file, and you're going to give it a name like so, filename.c. Before I do this though, I do want to change back to the C folder just so I'm not polluting my Docker folder here. So what I'm going to do is I'm going to go to users /Caleb, and then I'm going to go into desktop and then C. Now I'm going to touch filename.c, and when I list, you should be able to find file.c right there. Awesome. So once you create a file, you can always verify that you created it using the ls command. Now, what if we wanted to move a file? So let's say this file, we didn't mean to put it in the C folder, we just wanted to put it on the desktop. What do we do then? Well, what we can do is we just say move mv, and we say the original one, filename.c, and then we say where we want it to go. So we could say move it to the parent. Now, there should no longer be that file name here, but if we list the contents of the parent directory, it should be in there. So we listed the parent directory, and we have filename.c. Awesome. Now, what if we want to create a directory? So we have this C folder. What if we wanted to make a new one? Well, you use the mkdir command, make directory, and you can just give it any name. And then that should show up now as a directory when we list. And we are actually still in, I forgot to change directory, so we're actually still in the C directory. So we created this inside of the C folder. So if you wanted to delete that, it's real easy. You just say rm, awesome, and you're going to actually have to pass a flag when you're deleting a folder, and that is -r. But just to show you, when I try it, it says awesome is a directory, but that -r will get rid of it. All right, so we're currently in that C folder. We can make that directory in the desktop folder by going up one and then just saying mkdir awesome. And now it should be in the desktop as awesome right there. And we could, of course, we could navigate into that cd awesome, and you can see that there's nothing in there. You can also make multiple folders at once. So for example, you could say mkdir folder 1, folder 2, and they will both be created. Now there's a useful command echo that's basically going to print whatever you put in here back into the console, which obviously seems kind of useless right now, but you can do things with this. So for example, you could say echo hello world, and you can direct that output into a file such as output. And that's going to create a file output. And you can see the contents of a file using the cat command. Output, hello world. So that's pretty cool. Now, if you do it again, so for example, if I say hi and put that into output, now if we look at the contents of that file, you can see that it replaced hello world with hi. If you want to append to the file, you need to use two greater than signs. So you could say like this. Now, when we say cat output, it says hi there, which obviously I messed up because when you do this, it also has the new line characters. So this one plus a new line and then the space there. So obviously I failed, but you guys get the point. You can actually output any command to a file. So for example, if you don't want the output to be spit here, you can put it to a file. So I could say ls-la and I could direct that to a file ls output, for example. Now, if I say cat ls output, it puts all that information there. Now, there's actually another cool command you might want to know, and that is less. So this is another way to look at files, but it doesn't give you everything at once. And when you have a huge file, it's going to allow you to basically scroll through this, and when you're done, you can press Q. So that basically gives you the absolute basics of Linux. Obviously, there's not a strong order to any of this. I just kind of spit a bunch of commands at you. But honestly, just use the reference guide because that's going to give you what you need when you're trying to do something specific. So thank you guys. Hopefully that was helpful for you guys. And please be sure to check out the next video because we're going to be creating our first C program and talk about basic input and output. So it's definitely going to be fun. I'll see you guys then. Hey everyone, welcome back. This is the video where we're going to create our first C program. By the end of this video, you should be able to tell everyone that you're a C programmer, put that on your job apps. We're not going to get into anything too crazy, but this is going to really help you out if you're a beginner. If you're not a beginner, some of this might be pretty simple, but I still think it's good to go through it. So when we're creating a C file, we need to give it a name and then end it with .c. And that is, we're going to reference this file name when we're compiling. So the very first thing you should do is worry about the shell of the C program. So what I mean by that is anytime we create a C program, we're going to have a basic structure that is pretty similar for all of our C programs. And it looks something like this. We're going to have pound include, and then we're going to use standard io.h. So an include statement just allows us to use functions from this library here. Then we're going to create a function, and it looks like this. And you don't have to worry about all of this if you're a beginner, but essentially the main function is going to execute when our program is ran, and the return basically just says everything went okay, which is what the 0 means in this case. Okay, so we got our shell. Now what we need to do is we need to compile. So to compile, you use GCC and then you put the file name, 1.3, and then once you got enough, you can just put tab and it'll fill out the rest. Okay, so what now? Well, what happens when you do that is it actually creates a file a.out in your folder. And you can execute this by typing ./a.out. And you can see it does nothing, which is fine because our program actually doesn't really do anything. It just starts and then ends. So it's working. So that's great. Now this a.out is kind of a funny name. You can change that. So for example, you could say GCC and then use this O flag and give it a name such as tacos. And then we could say 1.3, put the file name. And now we have this file, tacos. So you can call that the same way, ./tacos. And you can see it still does nothing, so that's good. But I'm going to get rid of tacos, and we're just going to use a.out for this. Okay, so let's actually make a program that does something. Typically, the first program you're going to make is a hello world, and you're going to do that with the printf function, which is just a simple function to print things to the console. And in here, you're going to pass a string, which is indicated with a double quote at the beginning and a double quote at the end. All right, so just how it is now, it's going to print hello world and then immediately print this right after it without even a space. So what I would like to do is put a \n. So this is going to be rendered as a new line, and it's just going to make things a lot prettier. So we can compile now, and anytime you make a change that you want to see in the output of your code, you need to save the file, so Command S, and then you need to compile. So every change you have to compile. So don't forget that, or what you're going to be doing is you're going to be executing old code and you're not going to see any of your changes. So you need to compile. And if you have to continually execute that, you can just press up to get some of your previous commands, which makes it a lot easier for you. You can see it printed hello world. Whoop whoop. So there is your official program. You guys are all now certified C programming experts. Okay, let's do some more complicated stuff. Let's talk about variables. And we're going to get a lot into variables in future videos, so I'm not going to really explain a ton of this or get in a ton of detail. But creating a variable looks like this. And essentially what that does is it allows us to use this name x throughout our program to reference the value 50. So this x is known as the identifier, it's the name. So an identifier is literally just a fancy name for name. So when we reference x, or basically when we're using x, it's going to give us the value 50. It just makes our life a lot easier being able to store data in these variables and get access to them using the identifier. So we'll see that some upcoming. This here is actually a two-step process though. We're doing two things at once, we just don't see it here. So let's create another variable, int y. And what this is the declaration. We're basically just saying, hey, here's a variable y. The next part is the initialization. And this is done with the assignment operator. So assignment operator just takes a value and stores it in a variable. Super, super simple. And there are a lot of other operators we're going to talk about in the upcoming videos. So that is your basics with variables. Now what I want to do is I want to talk a little bit more about print statements and just how to make them a little bit more complicated using these variables. So for example, we can say printf, and the very first thing you need to know is that you can use format strings to basically parameterize your strings and allow you to input different values in different spots. So if that makes absolutely no sense, let's just recreate this string using a format string. So it's going to look like this. %s. And then we'll say world. Okay, so what in the world is going on here? So this s here can basically take any string and print it right here. And all you have to do is put that value after this entire string with a comma. So we could put in here hello. So this is kind of confusing, but basically what's happening is this is going to be put here where this s is. It's going to get rid of this %s and put hello, and then world is going to show up there. So let's just see this in action. Make sure you save. You can see it prints hello world. It looks exactly the same. But we can actually use this concept to our advantage and print variables. So for example, I can print the value of x. And to do this, we actually need to use a %d. And then a comma, and then we just put x. And always try to remember to put a new line. It just makes it a lot easier. The value of x is 50. So now you can kind of see we can reference the value 50 throughout our program. Even if we had this line 20 times and we had x 20 times, well, we could change the value of x in one location and it would update throughout our entire program. So it makes our lives a lot easier. And you can expand this concept to multiple variables. So for example, I could say x is %d, y is %d. And then we can pass in those two variables. And when we run that, we get x is 50, y is 10. Awesome. So those are like the most basic things that you're going to do. And you might be wondering, what is up with this %s and this %d? How do you know that it's an s or a d? Well, this is known as the conversion characters. So s is going to do strings, d is going to do integer data. So you can actually check out the syntax reference. There's going to be a list of conversion characters that you can do, but the most common ones you're going to use are s and d. So that is that. Now that you are a printing expert, the next thing you're likely going to want to do is get user input. So this is going to allow us to make our applications more dynamic, so we could ask the user questions. So to do this, we actually need to use a function scanf, and it's similar to printf, but there's a little bit of a difference that I'm going to be talking about. So this is going to take two things. By the way, these two things are known as arguments. When we're passing data into one of these functions, they're known as arguments. So the first one is going to be that string, the format string. And then the next one is going to be a variable, the variable that we want to store the value in. So we should actually make a variable ahead of time before calling this scanf. So for example, let's say we wanted to get a value for a radius or something. It doesn't matter, you can name it whatever you want. This name is just for our use here. So what we can do now is we can put radius here, but we can't just leave it like this. We actually have to use this ampersand symbol, which is a capital 7, the and sign. And this is a little funky and it takes some time to get used to, but basically what's going on here is that anytime we need to change the value of a variable, we have to use this and sign. This is known as the address of operator, and it basically gives a pointer. And we're going to get into pointers later, so don't get overwhelmed. I'm trying to balance out the content here for beginners as well as people who do know some of this stuff. So if you're a beginner and you're getting swamped, just go through this a couple times. And if you know all this, then just watch it and go on to the next video. So anytime we want to change the value of a variable, we need to have the address of operator. And that's because inside of this function, the only way for it to be able to change the value of radius is if it is actually a pointer to radius. And that'll make a lot more sense once we talk about pointers. The exception to this is when we're working with arrays, you don't need to put the and sign there. You don't need to use the address of operator. But in this case, we're just working with an integer variable, so it should be good. And as a general rule, anytime you ask the user for input, you should tell them so they know what to do. Just like this. And then what we can do is we can actually print this value out. So you could say something like, you chose the value %d for the format, and then we can just say radius. All right, let's compile, see if we messed anything up. Looks good. It prints hello world twice, prints some other stuff. Give me a radius. And I could say 734, press enter, and it says you chose the value 734. So this is pretty cool because this gives us the opportunity to make our program do different things based on the input from the user. And that'll make more sense once we talk about branching and control flow. But for now, just being able to get user input and output that input is very helpful to us. The next thing I wanted to talk about is strings. So I'm just going to get a little bit into this. Strings in C can be a huge pain in the butt when you're starting, and even even after using them for a while, they're just kind of a pain, and it takes a lot of time to get used to. So a string looks like this. This is an example of a string. It's just a sequence of characters encapsulated in double quotes. So if you wanted to store something like this in C, you actually have to use a character array. And an array is just a collection of data points, so something like this. So what we're doing is we're making a character array of 20 characters. Now the important thing to know with C arrays is that you need to reserve one character for what's known as the Null Terminator. And it looks like this, \0. And what this does is it indicates the end of the string. And this always needs to be there or else things can go very bad, because it's used to know that the string is done or that the string is over. And if by chance you overwrote this on accident and put a character there, well then some of the functions are not going to be able to tell that your string is over, and it's going to start accessing areas of memory that you're not supposed to access. So that's bad. You don't want to do that. So what that means is we need to leave one spot. That means we can only store 19 characters in this string. So when we say scanf to get someone's name, we're going to use the %s to say, hey, they're going to pass us a string, but you're going to want to specify that you want only 19 characters, and that is how you do that here. And then we're going to store that inside of name. Now, if you remember the previous scanf, we used the address of operator. We don't have to do that here because it's a character array. And anytime we're using an array, it's automatically going to be editable inside of the function because arrays decay to pointers. And we'll talk about that a ton when we get into pointers. Maybe not a ton, but enough to be enough. All right. So let's try this, and then let's just print out the name here. So %s. All right, give them a radius. Now it's asking for the name. I forgot to do a prompt. Caleb, and it says your name is Caleb. Great, so it's working. And if you want, you can add a prompt task for a name, but I'm just going to go on. So this video should have helped you get the basics of input and output, as well as working with variables and operators and even some strings. Ooh. Hopefully this video has been helpful. Let me know what you guys think of the course so far. In the next video, we're going to be talking about, shoot, totally just forgot. We're going to be talking about variables and data types, and just get some more hands-on experience with those. So be sure to check that out. Thank you guys. Welcome back, everybody. This video we are going to be talking about variables and data types. Now the very first thing you're going to want to know is that C programming is what's known as a statically typed programming language. And that is in contrast to what's known as a dynamically typed programming language. So what are the differences? So a statically typed programming language like C, you have to say what type a variable is when you declare it. So for example, A is of type integer. And that means A can only ever store an integer. In a dynamically typed language, variables are not tied to a data type, so you can assign it one type and then later switch the type that is stored in the variable. Each one has its ups and downs, so I'm not going to get in an argument of which is better. They're just different, and that's what you really need to understand. One of the benefits of statically typed variables is that you get more errors when you compile versus logical errors when you run the program. So in a dynamically typed language, and maybe this is getting a little bit into my opinion, personally, I find that I get a lot of issues with types and not getting the values that I was expected, because during the program's execution, the type of the variable is able to change. Whereas for a statically typed language, I'm not able to do any kind of changing of types. And if I do, I'll get a compiling error. So I'm able to catch more of the errors early on before executing the code. but different people have different preferences, so yeah, that's all I'm going to say about that. So we have integer here, but what are some of the other types? Well, there's double, and that's literally just basically the same thing, but now you can have a decimal afterwards. There's also float, and this is slightly different than a double, and I'll explain that. And the main thing is that a double is a 64-bit number, and a float is a 32-bit number. So when you're representing numbers in binary, the more bits you have, the more precise you're able to represent a number. So for example, you can do this. You can actually show that it's a 64-bit number by, I'm going to use %d here, but I'll show you that you're not actually going to want to use %d here, but you'll see in a second. You're going to want to use %lu, but if you use the wrong one, it'll let you know when you're compiling. So you can use this size of function and put in b, and when you compile, you get this warning, and it says, hey, you need to use %lu. I just wanted to call that out just because it's kind of cool. So you don't have to worry too much about the conversion characters because the compiler can help you out with that. But in this situation, you definitely want to use lu because it's a unsigned long, and unsigned just means that it's only positive. So now we can execute this, and we get the value 8. So what does 8 mean? Well, it's 8 bytes, and a byte is 8 bits, so 8 times 8 is 64. Now if we do the same exact thing, but we use C instead, now we're going to pass in C. This is going to give us the value 4. There we go, we get the value 4. So that is the difference between float and double. Generally, I use double all of the time. The only time you'd want to use float is if you're really constrained in memory size, which I only ever program on a desktop computer that has plenty of memory, so I never run into those kinds of issues. But it is kind of important with C programming because often C programs will be executed on much weaker devices. So definitely understand the difference between double and float. All right, so what other types are there? Well, there's character. So this is going to look like single quote A. And this is kind of confusing because the name is D and we're giving it the value A. But a character just stores one letter. The next one we have is an array, a string, I guess, a character array. And this is aka a string. And then the last one I have for you guys is bool. And this is either true or false. Now when you do this, you're going to have to use this standard bool.h include. Otherwise, it's not going to recognize this. All right, so those are the main data types that you should know about. The next thing I wanted to talk about is just legal identifiers. So once again, an identifier is just the name of the variable. And you can see that these all are legal because when we compile, we don't get any issues. But if I did something like int, I don't know, 5 cats, this is not going to work. And that's because we're starting our variable name with a number, which you can't do. So in general, you want to use just characters. You can put a number inside of the variable name or at the end, and that works fine too. So that's okay. And when it comes to capitalization, it's important to know that cats and cats is not the same thing. So same for this, that's different as well. Any kind of capitalization differences is a different variable because C is case sensitive, meaning that when we change the keywords or words to different capitalization, it makes a different word. So for example, int in all capitals is not the same thing as int in lowercase. So I think you could even do this, which you wouldn't want to do, but I'm just showing you that this is not the same thing as the lowercase version. If you did the lowercase version, it wouldn't work because you're not allowed to use keywords as identifier names. You can start them with identifier names, but you're not able to use the full keyword. So all of these are legal identifiers, but they're not all exactly the most recommended. So what I recommend when it comes to just pure convention, like what you should do, I like to start with a lowercase and use camel case, which is where the first word is lowercase and then all the other words start with an uppercase letter. So cats are okay. That would work. I was going to say cats are awesome, but then I was like, dogs are kind of cooler. Yeah. All right, so that's just a little bit on identifier names. And the next thing I wanted to talk about is just what's known as implicit type conversion. And it's just important to know really some of the basics of this. And if you really need to get into the details, you can. But the thing is that it's possible for C to implicitly, meaning you don't have to tell it to, change the type of values to meet some expectations. So for example, if I did int x, actually let's go with int 0 equals 0.999999. This is interesting because we're storing a decimal value, but it's being stored into an integer variable. So what exactly is the end result? Well, I hope you got the hint that it's going to be 0, which I hope I'm correct. And then we just pass in the 0 variable. Make sure you put the return at the bottom. You should still be able to run this because it's only a warning. And you can see that 0 is 0. So that is an example of implicit type conversion. The next thing I wanted to talk to you about was typecasting. And this is more explicit in that you tell the compiler that you want to do a cast versus the implicit where it just does it for you automatically. And honestly, the only way to truly understand anything in computer science is to use the example of ordering a pizza and splitting it amongst all of your friend. So let's say we get a pizza and it happens to have 17 slices. I know it's such a weird way to cut a pizza, but you know. And we're gonna split that between me and someone else. Now, if we do something like this, slices per person, the way you would figure out the answer is, you take 17 and you split that between the people. And you would expect getting, and what you would expect is not what you actually get, just so you guys know. So you would expect to get 9, 8, freak, I can't do math. Sorry guys, I was put on the spot because I'm making videos and therefore my brain just shuts off and I can't think about normal, simple math problems. But basically, what you would expect to get in real life, if you had 17 pieces of pizza and you split it between 2 people, you would get 8.5 slices each. But it's not going to work that way in C programming because these are both integers. And when you're dividing an integer by an integer in C, you're actually only capable of getting an integer. So the result is actually going to be 8. So if we took that and we printed it out, LF for double. I had to think about that one for a minute. We still have that. This warning is from that earlier implicit type conversion. I'm going to comment that out so it doesn't bother me every 5 seconds. All right, so we get the value 8.00000. So you can see that it's still stored as a double, but the actual value would be capable of being stored in an integer because all it is 8. So in order to do this, we have to do explicit typecasting. So the way we do this is we need to, in parentheses, put the keyword double. And this will cast slices to a double. So now it's not going to be 17, it's going to be 17.0. And the important thing to realize here is that we're changing the value, but we're not changing the variable slices. Sorry, that was kind of a confusing way to explain it. The type of slices is not possible to change. So slices is going to remain a 17 integer. And this, anytime we do typecasting like this, it only affects the value in the expression. There we go. And we get 8.5. So that is how you do explicit type conversion. And the important thing to realize is that this is what's known as a unary operator. So once we get into operators, it'll make more sense, but it's only going to work on one thing. So if we put it next to slices, it works on slices. If we were to do something like, let me get rid of this comment, like this, that's still not going to give us the value because double is only going to work on one thing, and whatever's in parentheses is evaluated first. So this is going to evaluate to 8, and then it's going to be typecasted to double and give you 8.0, which is what it's going to do anyways because it's being stored as a double. So we're going to cast slices to double, and those parentheses there are totally fine. Yep, there we go. This expression is using double division because slices was casted to a double. But the thing to know is that if we had a large expression with lots of integers, it's not going to use integer division for all of it, only the parts where one of the operands of this division operator is a double. So if that doesn't make any sense by me explaining it, let's just go through a simple example and we'll see what we get. So let's say we have test 1 and we take the values 25 divided by 2 times 2. And I want you guys to think about what this is going to output. Now, test 2 is going to be 25 divided by 2 times 2.0. Haha, gotcha there. Okay, so I'm going to give you the answer. Both of these are going to evaluate to 24.0. And this kind of just shows that just because we have a double in here, it doesn't mean that all of the expression is done using double arithmetic. So let's go through how this would be evaluated. It's going to look like this when it's evaluated. So 25 divided by 2 is going to, and because these are our integers, it's going to give us 12. And then we take 12, multiply that by 2, get 24, and then that's stored into a double. So we get that 0.0. The other one, it's going to do the same exact thing. 25 divided by 2 is 12, multiply that by 2.0, we get 24.0, and that's stored in test 2. So what exactly am I trying to show you here? The main thing that I'm trying to show is that when there's a double in the expression, like 2.0, it only affects the multiplication that it's attached to. So basically this times this using double arithmetic. So hopefully that is clear as mud. If you wanted to fix this, you would do something like this. So let's create some new variables. So you could do 25.0 divided by 2 and then multiply that by 2. That's going to give us 25. Alternatively, you could use the typecasting like shown in the previous example right here. So you could say double 25. Either one works fine, whatever you prefer. Divide that by 2, and then multiply that by 2 or 2.0. So now, the important part, the part that is giving us a funny result, this right here, is now using double division, thus giving us a double result. So these should both evaluate to 25.0. Not integers, because they're being stored as doubles. So just to prove my point, I'm going to put these print statements in here and just see what the values are. Test 4, sorry. Test 3, 25, test 4, 25. And to prove that these two were actually 24, we could switch this to 1 and 2. And we get 24. So hopefully I didn't go too much into detail there. The main thing you guys got to get from this is that you got to be super, super careful when we're dealing with expressions and the mixture of doubles and integers. If you ever want to get a double result, you probably want to make sure that all of the operands in your giant expression are of type double. All right, so that's all I got for you guys in this video. Hopefully it was clear and helpful, and I'll see you in the next one. Welcome back, everybody. This video, we're going to be talking about operators. Now, I figured the best way to explain this would actually just be to go through the code examples and just go through the examples and explain why we get the results that are given, rather than me trying to type everything out, because this has a lot of print statements. So the first thing you're going to notice in this is that there is a ton of operators. If you're new to operators, it can be slightly overwhelming, but what I'm just going to tell you is that none of the operators are extremely complex or difficult. It just takes time to go through the entire list. So give it time, and it'll come with a little bit of time and effort. So the very first thing is that you can actually categorize operators by the number of things that the operators work on. So for example, if you have something like 5 plus 5, well, and like you can assign this to something in x equals 5 plus 5, for example. Well, this is an example of an expression. So operators are used to create expressions, and the operators work on what are known as operands. So these 5s are operands. So you can see that the plus has 2 operands. That means it is a binary operator. Now there's actually unary operators, binary operators, and ternary operators, which work on 3. And there's one of those, and we're going to be talking about that later, which that one is actually the last one on this list, the conditional operator, which uses 3 operands. So that's one way to categorize it, but you can also categorize it sort of by use. So plus and minus, arithmetic, increment, decrement, assignment, and so forth. So however it helps you guys to think about it, just understand that usually grouping things into groups helps you to organize it in your brain and to truly understand. Now the plus and minus here, these are unary, meaning it works on 1 operand. This is not the plus and minus in the sense of addition and subtraction. This is plus and minus in the sense of positive and negative. The next we have the arithmetic, which is used to do math. We have the increment and decrement, which increases or decreases the value of a variable by 1. We have the assignment operators. We've talked about this assignment operator here on line 25, but we haven't gone through all of these, which just allow us to do some more complex examples, which we'll be talking about later in this video. Now the comparison and logical and conditional, we're going to be talking about in the future once we start getting into if statements and other more complex programming concepts. But for now, we're just going to start with the basics, and then getting these will be very simple. But just to give you the basics of these comparison are going to compare 2 values and give you true or false as a result. So this one's going to compare if something's equal, this one's going to see if something is less than something else, and so forth. The logical operators allow us to make more complex comparisons. And lastly, the conditional operator is kind of like an if statement, which we'll be talking about here shortly. All right, so that was kind of like my preamble. Now, on to the actual good stuff. The first thing you should understand is the concept of precedence. Now, precedence is taught in school when we're talking about math. So, for example, typically if you have multiplication and holy crap, my air conditioner just came on and scared me. You have parentheses. I totally lost my train of thought. So if you have multiplication and addition in the same expression, well, the multiplication typically happens first in like normal math. Well, the same thing happens in C programming. And you can force different precedents using parentheses. So that's the whole concept behind precedence. If you want a good reference, here is one for you guys. Let me show you this real quick. So you can see that all of these operators have precedence 1, meaning they happen first. These ones have precedence 2, and so forth. So I have an example of that here, where we have 2 times, and then we have these parentheses. So we're basically using the parentheses to decide which way we want this expression to be evaluated. If we didn't use parentheses, it would default to something. So like, let's try this. 2 times 3 plus 3. The default is that because multiplication has the highest precedence compared to the addition, these 2 will happen first. So it will evaluate like this one down here. Now, in this scenario, these parentheses are not actually doing anything. The only thing it's doing is helping it be more clear to the programmer. So if you want to be more explicit in showing how the expression is going to be evaluated, even if the parentheses are not needed, they can still be extremely helpful just to prevent bugs or incorrect evaluation of expressions. So I definitely recommend using parentheses whenever you can. You can use them to both force precedence, such as in this case, we're forcing the 3 plus 3 to happen first, or you can use it just to indicate how the expression is going to be evaluated. So that is up to you, how you want to use those, but I recommend using parentheses anytime you can. So in this case, x, what is the value going to be? 3 plus 3 is going to happen first, which is going to give us 6. And we're going to multiply that by 2, which is going to give us 12. So x will be 12, and then y is going to be 2 times 3, which is 6, plus 3, 9. And you can see that when we print these out, those are the exact values we get, 12 and 9. The next thing I wanted to talk about is the modulus operator. And if you scroll up in our reference here, that is actually in the arithmetic. The first 4 in here are pretty simple, and I just decided not to cover them. So this is addition, subtraction, multiplication, or division, and multiplication. Those are very commonly understood, so I decided to pass. The only thing is you might need to get used to these characters if you're used to the more mathematical symbols. So this is the / and the asterisk, capital 8. The only one we haven't really familiarized ourselves with in school is this modulus, which is the remainder of some integer division. So let's look at that. So what happens is in this example, we take 10, you can consider whatever you want it to be, 10 slices of pizza, divide that amongst 3 people, and whatever is left is what is assigned to C. And you can't split the slices of pizza, so this is integer division. So we're going to evenly be able to divide 9 slices of pizza amongst 3 people, and we're going to have 1 left over. So 10 modulus 3 is equal to 1. You might think, oh, how is this going to be useful? But the modulus operator can actually do a lot of cool stuff. It's one of these magical operators. Now the unary minus is pretty easy to understand. If we have a variable a equal to 5, and then we set b equal to negative a, b is going to have the value negative 5, which is exactly what we get when we print it out here. And the important thing to see here is that a doesn't change. So even though we use this negative a, the original value of a stays the same. And that's important because once we start talking about increment and decrement, it doesn't work that way. So now let's talk about increment and decrement. This is one of the most useful and most common operators seen in programming because it makes our lives a lot easier. So to understand an increment, if you do something like a++, it's going to take the value of a and increase it 1, and it's going to affect the variable. So the value stored in the variable a is going to be 1 higher than it used to be. So this is basically the same as doing a equals a plus 1, which would work, but it's just been condensed to this a++. Now, the interesting part is that you can actually assign this to a variable like I'm doing here on line 75 right now. And what exactly happens when we do that? Well, the thing to know is that b gets assigned to first. So it's going to be b is equal to 5, and then we increment a, and a is equal to 6. So when we do this post increment, it's called post increment because the double pluses, the increment operator is on the right hand side of the a. It comes last or after a. So b is going to be 5 and a is going to be 6. This is different than the pre-increment. So the pre-increment works differently. So we started fresh by setting these both equal to 5 again, and then we did plus plus a. And now what happens is this plus plus gets evaluated first, and then we assign that value to b. So now they're both going to be 6. That's just important to understand the difference, and usually you'll see this in the real world, but this is still a thing. And honestly, if you just do it by itself, like a++ or plus plus a, it makes no difference. The only time it really matters is if you're passing this value into a function or assigning it to a variable. All right, so now let's talk about some of these assignment operators. Well, we've been using this original assignment operator a ton. So A equals 5. A is assigned the value 5 is essentially what we're doing. But there's actually some of these other ones which have these math operators before the equal sign. So going back to what we had earlier, we had A is equal to A plus 1. This could alternatively be written with the increment operator like so, A plus plus. But even another way to write this would be A plus equals 1. And that is what we're showing here. So when you do plus equals something, it's going to change the variable A by that amount using this operator. So in this case, it's going to increment it by 1, but we could increment it by 10, we can increment it by 100, and we could use these other operators too. So we could multiply the value by 100, we could divide the value by 100, and so forth. So these alter the original variable value, and that's important to understand. So let's look at the example we have. We set A and B both equal to 5. And what we do is we do B plus equals A. So what that's going to do is it's going to increase the value of B by however much A is. So B should be 10, and A is going to remain 5. Cool. Now what we do is we do a multiplication. So this is just going to change the value of A by multiplying it by 30, and we get 150. Lastly, we have 150, and we basically take the modulus of 140, which would result in 10, because there's going to be 10 left over. So that is kind of your crash course on operator precedence. Now I wanted to talk not just precedence, but just how to use the different operators. And the precedence is with the parentheses I showed you up here. But the other thing I wanted to show you is the associativity. Now, what is associativity? If we bring up this chart again, let me get my Chrome up. It's not working. All right, so the associativity is when we have operators that are of the same precedence. The associativity is how they get evaluated, either left to right or right to left. Typically, you're going to see left to right, and that's really what most people are most comfortable with, but on occasion, there are right to left. So for example, the assignment operators are right to left. And the only time this really matters is if you have multiple operators in the same expression that have the same precedence level. So for example, this is actually a perfect example. If we have int x equals 2 times 3 plus 3, or not 3, let's say divided by 3. Let's just go through this as a theoretical example. Well, you know that this is going to be grouped like so, because we evaluate left to right. And the reason that makes sense is because the multiplication and the division have the same precedence. So then we go to the associativity to define how they are evaluated, which is from left to right. So we do this one first, and then we get that result and divide it by 3. So that is the basics of precedence and associativity and operators. I hope that was super helpful for you guys. A lot of these other ones are going to make a lot more sense once we talk about if statements. So thank you guys. I'll see you in the next video. Welcome everybody. In this video we are going to be talking about logic. So this includes if statements and the variations, as well as switch statements and the conditional, also known as ternary operator. So we're going to talk about all of these things and just help you guys understand how we can do branching and conditional output in our code. So this stuff is pretty cool because this is where our code starts to become like more useful beyond just calculating things. Like we're able to take input and do different things based on that input and so forth. So this is like the basis for more complex programming. Yeah, it's going to be pretty sweet. We're also going to be talking about some of the other operators we didn't talk about in the previous video. So the very first thing is an if statement. And the way an if statement works is you put the if keyword and then you put parentheses and then you put a code block with these curly braces. Now, essentially what happens is whatever you put inside of these parentheses evaluates to either true or false. So you can put any kind of expression in here, and if it evaluates to true, this code block will be executed. If it evaluates to false, it'll continue on past the if statement. So the easiest way to show an if statement is literally to just type true here. Or you could use 1. If you don't want to include standard bool.h, you could use 1 there. So we'll try true. And then inside of here, you could say anything you want. And when we compile this, it will execute this is true. But as you can probably tell, this is kind of pointless because it's going to say this every single time. So you might as well just not even put this if statement at all. And in fact, I don't know if the C compilers do this or not, but I know compilers are capable of looking at if statements such as this one and realizing, hey, moron, this is going to execute every single time. So we're just going to get rid of this part and this part down here and just keep that. I'm not sure if that's happening here or not, though. Okay, so the other scenario or the other variation of the if statement is the if-else. And what happens here is if it's evaluated as false, this path will execute. All right, so when we compile, the same thing's going to happen. This is true. But if I go in here and put false, it now says this is false. So that is an if-else statement. So now that you understand the basics of the if statement, let's turn this false into something more useful, because right now this doesn't offer us any benefit. So we're going to create a variable and say int age equals 17. So now we can do comparisons against this age, and this brings in those other operators we were talking about. So if your age is greater than 17, you could say this is adult, and this is no adult for the false case. So now what's going to happen? Well, age is equal to 17, and this is going to be compared against 17. Is 17 greater than 17? The answer is going to be false. So we should get this is no adult. Awesome. So now you can kind of see that it's a little bit more useful. Obviously, it's still hard-coded, so it's not super useful, but eventually you're going to be able to get this value from a database, from a file, from user input, and make your application more dynamic. The next thing we're going to talk about is logical operators. The first one you should know about is the not operator. So what this will do is it'll flip any expression. If it evaluates to true, it'll make it evaluate to false. If it evaluates to false, it'll make it evaluate to true. So to do it, you can basically take an expression, wrap it in parentheses, and put an exclamation mark right before it. And now whatever this evaluates to, it'll flip it because we have this exclamation or the not operator right before it. So this once evaluated to false here, but now it'll evaluate to true. And you can see it says this is adult, even though age is not greater than 17. So this evaluates to false, we flip it to true, and then this is executed. So that's the first one. The next logical operator is the AND operator. And it looks like this, 2 ampersands or capital 7s. So for example, we could have another variable like money equal to 30,000. And notice there's no comma here. That's important. And what we could say, money is greater than 25,000, which is true because we have 30,000 monies. But this is still not going to evaluate to true because the way the AND operator works is that both parts need to evaluate to true. So age has to be greater than 17 and money has to be greater than 25,000. So you can see we still get false. And I'm just going to get rid of these adult things and just make it general true because we're going to go through a bunch of examples. Okay. So now it should say nothing because we don't have an else statement. The other one is the OR operator. And this will evaluate to true if either this evaluates to true or this evaluates to true. And as you know, we have 30,000 money. So this will evaluate to true and we'll get that print statement. There you go. So those are the logical operators. Now there is one warning I have for you guys. And that is if you mix and or operators in the same expression, you introduce a level of ambiguity. And in fact, the compiler will give you a warning about it if you do it. So that is definitely helpful. So to illustrate this, I'm going to switch that back to and. And let's say we have a Boolean variable is graduated. And we'll set it equal to true. And then we'll append to this or is graduated. Okay, now it's really not clear unless you really know what's going on, because you can't tell where the expression would essentially put parentheses if it did that. So like, let me just draw out the possibilities to make it really clear for you guys. One possibility is that these get evaluated first. So this and then that whole expression is ORed with is graduated. The other possibility is that these get grouped together. So these get evaluated first, and that's ANDed with this expression over here. So which one happens actually is the first one. So this is the default behavior where it is evaluated left to right, and that keyword is associativity, which we talked about in the previous video. So this is going to evaluate, and then if this is true or false, that'll be evaluated with is graduated. So in this scenario, because is graduated is true, it doesn't even matter what's over here. This will print this is true. And you can see we get this is true. The other one is a little bit different, because this one, because we forced the parentheses on here, money is greater than 25,000. This is true, so this entire thing is evaluated as true. But the thing is, age is not greater than 17. So when this is evaluated, the first thing is, oh, age is not greater than 17. Boom, that's enough to know that this is not true, and we can move on. We don't even have to evaluate this here. So that's why this one is not executed. And just to be sure, I'm going to put a 1 here because they both have the same output. So this is true 1. The next thing I wanted to talk about is the if, else if statement. And the way this works is, well, first I'm going to clean this up because we don't need all this. Let's just go back to age, and we'll just get rid of all this here. So we can create a normal if statement, and let's say if age is, I don't know, less than 12, we could do something. Well, instead of saying age is less than 12 or anybody who's 12 or older, you can actually subdivide the group of population a little bit more by doing an else if. So you could say if age is greater than or equal to 12 and age is less than 20, for example. Then we're going to do something else. And lastly, we can still have an else statement at the bottom. Now, the next thing I wanted to talk about is single line if statements. And these are dangerous, but also very cool. Okay, so let me get rid of all this stuff. Basically, what we can do is say, hey, if age is less than 150, then I want to do something. So let's say printf, you might be alive. Okay, so this is a one-line if statement. You don't have to use the curly braces, and it works just the same. So this will print you might be alive, but if I'm actually 170, it won't do anything. Cool, so the danger here is that it's very easy to forget that you can only do one statement. Oftentimes, people will put a second statement in here to be evaluated if this is true, and that's not what you want to do. You can only do one, and that's it. So for example, if I said, yep, this is going to print every single time no matter what. So you might be alive, yep. And if I make my age 170, it still prints yep. And you'll often see this when the statements to execute are on the next line, like so, because it's really easy to just go in here and add a new line because it's indented. It looks like it's part of the if statement, but it's not. So that's the only warning I have for that. My recommendation is if you're going to use a single line if, make sure you just put it on one line, because it's a lot easier to realize, hey dude, there's no curly braces. I'm just doing one statement here, the end. The next thing I wanted to talk about is the switch statement. So the switch statement can do a lot of similar things to the if statement. It's actually a little less useful in my opinion, but it's still kind of cool. I think it's easier to read for certain situations, but not always. So to do a switch, you'll need an integer-based data type. So that can be integer or it could be character. And then you say switch, and then in parentheses you put the variable name there. And then everything goes inside of the curly braces. So that all matches the if structure, but this is not going to be evaluated to true and false. it's going to be evaluated to different possible values or cases. So if it's 0, we're going to do something. If it's a 1, we're going to do something. If it's a 2, we're going to do something, and so forth. And then lastly, you can have a default case. Now, before you go coding things in here, you want to put a keyword, and just trust me, break. You'll need to put this after every single one. I'll explain what that does in just a minute. Now, before the break, you can put any code you want. Case 0, and I'm going to do that for all the cases. And then lastly, the default case. So now let's execute this and see what happens. You can see that it hits case 2. So it comes down here. What's the value? 0? Nope. 1? Nope. Case 2? Yes, it is the value 2. Thus, this is what happens. And you can put multiple statements in here. It doesn't just have to be one, but just for illustration here, this is nice and simple. Now you might be wondering, what's up with this break keyword? And it's kind of silly, honestly, but you have to put this break keyword to prevent it from falling through and executing these other statements. It's kind of stupid, I know, but if you don't put it in there, bad things will happen. So for example, let's get rid of these breaks, and let's say the value of menu choice is 0. Well now, when I execute this, it hits case 0, prints this, and then it falls through and does the print statements for all of these cases. So it's really, really super important to put the break. I would even put it in the default case as well. Now there is one other thing you can do for the switch statement, and that is you can have multiple cases execute the same. Kava. Sorry guys, my dog is interrupting. Hi girl, how you doing? You a good girl? So as I was saying, you can have multiple cases execute the same statement. And to do that, you just put them in a line like this. And I could say 0, 1, or 2. So if you want the same thing to happen for multiple cases, that's how you would do that. And let's say our menu choice is 1. You can see that it hit this case right here, and then it fell through and hit the others because I forgot to put the breaks back in. See, I told you they were important. So that is the switch statement. The last thing I wanted to show you guys in this video is the conditional operator. So I'm just going to get rid of everything here. Let's say we have a variable balance, like a bank balance. And you know, pretty typical amount, -5,000. And what the ternary operator allows us to do is it allows us to basically do an if statement to start with. And if it's true, something happens. If it's false, something else happens. So the structure is you put an expression, balance greater than 0. Then you put a question mark. And the question mark is what happens if balance is greater than 0. So it evaluates to true. And you can print something here, for example. And you don't put a semicolon. That's important. It's odd, I know, but it goes at the end. Then what you do is you put a colon. And what the colon does is it says, hey, this is what I want to happen if it's false. So this is an example of a ternary operator. Let's execute it and see what happens. No money, yo. For some reason, this is the hardest thing for me to remember the syntax to. It's really simple, but I always end up having to look it up. But you can actually do some other cool stuff with this. So for example, we could have a Boolean variable, has money, for example. And we could say has money is equal to, and then we could use a ternary operator here. So we could say balance greater than 0. And it's kind of cool now that I think about it. It's just kind of like, it's kind of like a question. Balance greater than 0? If so, yes, we do have money. 1 evaluates to true. If not, no, we don't have money. 0 evaluates to false. Then we can just do a print statement. There we go. Has money? Nope, we don't. Oh man. All right, so this is basically giving you the introduction to if statements, switch statements, and the conditional operator. This is basically the basis for more complex applications, and hopefully this will give you what you need to know to start making some cool stuff. So thank you guys. The next video, we're going to start talking about loops, and that's going to be pretty sweet, so check it out. Welcome back, everybody. This video, we are going to be talking about loops. Now, loops are actually really cool because they allow us to execute some line of code or lines of code numerous times. And there are three types of loops. There is the for loop, the while loop, and the do while loop. And by the end of this video, I expect that you're a master in all three. Well, maybe not a master, but at least how to use them. So first, let's just talk about the fundamentals of all loops. There's things they all have in common. So there's three pieces that each loop needs to be functional, and that is an initialization of some variable, a comparison against that variable, and then an update of this variable. I guess I could just say update. So I remember this ICU. Basically, you're going to, for a pretty standard loop, you're going to have a variable such as I. It's typically called I. And you're going to say it starts as 0. So that's initializing. And then you're going to say, hey, as long as I is less than 1,000,000, we're going to keep running this loop. And then each time we're done with this loop, we're going to add 1 to I. So that's kind of like the basic structure, but it's a lot easier to see with just going through an example. So here's like a very simple loop, like the basic beginner loop. Int I equals 0. That's the initialization. I is less than 10. I++. And then in here, we can print something. Specifically, we'll typically use I to say something like to change the value within the loop, if that makes any sense at all. Basically, we don't just want to say the same thing each time. We want the print statement to depend on what loop iteration we're on. So the first iteration, I is going to be 0, so we're going to print 0. The next one is going to be 1, 2, and it's going to count up until 9. So let's print this out, and let's put a space here. My dog's going on barking on me and stuff. Oh gosh. Should probably go see if there's an axe murderer. It would appear that my house is axe murderer free, so that's good. So let's print this. Let's run this. You can see it starts at 0 and counts up to 9. So each loop iteration is the word. It's going to print the value I, which starts at 0, and every time we go through the loop, it increases 1 until it hits 10. As long as this is true, it's going to keep running, but once it hits 10, this is no longer true because 10 is not less than 10, and the loop stops. Now you can also use, we could use less than or equal to if you wanted to include 10, or we could start I at 1. There's all kinds of different things we could do. We could increase I by 2 each time. So you could say I plus 2, or we could multiply it. There's a bunch of different varieties of the for loop, and it's just important to understand that as long as you have these three pieces, you should be pretty good to go. Now, there's one other thing I wanted to mention. I'm not positive which versions of C require this, but it might be that, let me get this back to normal real quick. It might be that you have to declare I up here and then just say I is equal to 0. Either way works. It's exactly the same thing. You can also make a for loop to decrement. So for example, we could start at 9 and say, hey, as long as I is less than or equal to 0, we're going to decrement the value. And now it counts down from 9 to 0. So the thing here is that I changes each iteration, so you can use this to effectively iterate through an array and print all of the values. So for example, let me change this back to this here. What we could do is we could create an array. Let's say we have a group of ages. So we're just collecting the ages of all of our neighbors. All right, we got pretty good variety and then some super old guy. Now, what you can do is you can use a variable to keep track of the length. So you could say int length or int size, whatever you prefer. Int size equals 10. And what you can do is say I is equal to 0. And as long as I is less than size, increment I. Okay, so now what I wanted to mention here is that the size thing is kind of unnecessary because you could just put less than 10. But it's often helpful to put the size of the array in a variable, so if you need to reference it throughout the program, you can just write it here. And then, for example, if we added an element here, we could change size to 11. And anytime we reference size in our program, it would automatically update to this value 11. So it's not going to break our program. So we're going to keep that at 10. And also, in other languages, you'll often have something like ages.length or ages.size. Unfortunately, there's nothing quite like that in C. I will tell you the closest thing to it in just a minute. But for now, let's just print this array. So what we can do is we could say ages of I, and say that is equal to %d. And then what we need to pass in is not I, but ages of I. There we go. Let's see if this works. Cool, so we get every single value printed out all the way from 12 to 12. So we covered the whole basis. If you wanted to calculate the size of the array and not have to have a variable to store it, you can do that like this. Using the size of function, you can pass in the array, and then what you need to do is you need to divide it by the size of one of the elements, usually the first. So what exactly is this doing? Well, because each element is going to take up multiple bytes, we have to have that division in here, because this is just going to give us our total bytes. But let's say each element takes up 4 bytes. Well, then we need to divide it by 4 to get the size. So in here, I could replace this with calculated size, like this. And you can see it still works perfectly fine. The one warning I have for you is that if this is done inside of a function where you pass in an array like ages, it's not going to work. And that's because when you pass an array to a function, it decays to a pointer. And when you do something like size of ages on, let's say, a pointer, ages, it's not going to give you the size of the entire array here. It's only going to give you the size of the pointer. So it's not going to work. Here it works because we created the array in the same block that we're calculating it in. So it works. Just be warned, you don't want to try to do this inside of a function where you're passing an array as an argument. All right, enough on that. You can also have nested for loops. So for example, I could create a for loop here, int I equals 0, I is less than 10, I++. And then inside of this for loop, we could have another loop. So this loop is going to execute for every iteration of this outer for loop. And you can actually reference this variable inside of this for loop if you wanted to do something like that. So we could say int j is equal to I, for example, and then say, hey, as long as j is equal or greater than or equal to 0, we're going to count down. So basically what was going to happen, this loop's going to count upwards, and then for every iteration, it's going to take that iteration number and count down to 0. Kind of pointless, but kind of cool. It's totally useless, I'm just going to say. %d, and then the value we're going to pass in is j. And then down here, we're going to want to print a new line. Whoops. Just like so. All right, let me scroll this up a little bit. So you can see we're counting up from 0 to 9, and every single time we count down from the number we're on all the way down to 0. So that's some cool practice with for loops. You can also use nested for loops to iterate through 2D arrays if you want to look into that, and so forth. The next thing is while loops, and these work exactly the same way. So I'm just going to get rid of these for loops here. Let's just start fresh. We're going to have those same pieces though, so we need to initialize a variable, and then we're going to make the structure of our while loop, which looks like so. And then our comparison goes here. So we could say as long as I is less than 10, we're going to increment I. And then the code part goes here. So we could print I. And this will do the same thing as our original for loop. Count from 0 to 9. Awesome. The last thing is a do while loop, which is a little bit different because it's going to look like this. We're going to have a do, and then we're going to have our code block, and then we're going to have a while with a condition in it, followed by a semicolon. So this is our structure. So this is always going to be executed at least one time, and that is the difference between a do while loop and just a while loop. I usually use these for menus, so if I want the user to basically open the application and type 1 for something or type 2 for something else, and let's say they put in the number 645, well, I could basically say, hey, do display the menu while they're not giving a valid input. A very simple example of this is, let's say we want them to choose a number between 0 and 9. And then what we do is we scan F that number, and we're going to need a variable to store it in. It's going to be an integer, and we're going to store that inside of input. And we're going to keep asking them as long as input is less than 0 or input is greater than 9. So let's try this out. So when we run this, if we put anything that's not in that range, it's just going to keep asking us until we put a correct value, and then it ends. It probably makes sense to put this printf inside of the do loop actually, so that way it asks every time. Otherwise, it just kind of looks like it breaks. There we go. Now let's try. 60. Nope. Negative 10. 7. Once we put in a valid number, it stops. Awesome. So that is how you do for loops, while loops, and do while loops. Hopefully you guys understand the differences. The for loop and the while loop can do exactly the same thing. And it's even possible to take this do while loop and convert it to a while loop. You basically just have this print once beforehand, and then you do the for loop after or the while loop after. So you can basically do the same thing with all of these loops. It's just slightly variation in style and preference. Generally, if I have a list where I know the length, I'll use a for loop. If I want something to do something indefinitely, I'll use a while loop. And if I want something to execute at least once, I'll use a do while loop. So thank you guys. Hopefully that was helpful. In the next video, we're going to be talking about arrays. So check that out, guys. Welcome back, everybody, to your video dedicated to arrays. We've touched on them a little bit in the series so far, but we haven't gone in depth and just did a video dedicated to them. So hopefully by the end of this video, you have a pretty good understanding. Now, an array is just a collection of data elements that are all of the same type. So to declare one, you do this. In ages, and then you put the square brackets. Where ages is the identifier, you can name it whatever you like. And you have to give it a data type, meaning that each element has to be of this type. You can't mix types. You say that this is an array by putting these square brackets here. Now, this is just a piece of, extra information. Some other programming languages have you put these square brackets with the data type and not the variable. So for C and C++, it goes with the variable name, the identifier. Other languages such as C#, you put the square brackets with the data type. So just keep that in mind, try not to get too confused, and just understand that difference if you go into other programming languages. Now, if you're going to declare an array, you have to say what size this array is going to be. So you could say, hey, I want to make an array with 10 elements. And these elements each have an index. It's like the number that they get when they get put into the array. The first element gets the index 0. So it's 0-based indexing, so it goes from 0 to 9, where 9 is the 10th element. That is one of the most confusing things to get started with if you're new to arrays. It kind of takes some time to wrap your brain around it, and eventually it'll be like the default way of thinking about it. Okay, so this is a statically sized array, and what that means is that the size is determined at compile time. It's given that much space in memory, no more, and you can't go beyond that without accessing areas of memory you're not supposed to be touching. It's not very simple to create a dynamic array without using memory allocation, dynamic memory, and pointers. So in the upcoming videos, we're going to be talking about dynamic memory. But until then, all of our arrays are going to be statically sized, meaning if you don't know how many elements are going to be in this array, like let's say we want to have the user put in these ages by hand, we have to be sure that we give a number big enough to hold all of those elements, Or once they hit the max, we have to say, yo, dude, that's the highest number of ages we can contain. That's one of the big downsizes with this. In other programming languages, you'll have things like array lists, which are dynamically sized, but not so in C without using some more complicated stuff, which we'll be talking about soon. So enough blabbering. The way you add elements to this is you just say ages, and then inside of these square brackets, you can reference the index of that element. So if I wanted to get the 5th element, I would put 4, and then I could give it a value, such as 65. Now, this is one way to do it. You could literally go through and make an assignment for every single index, but that's kind of stupid because there's an easier way to do it, and it looks like this. And you're actually going to get rid of the size here. You're going to say equal, and use 2 curly braces, and you can just put the values in here. So now, it's still a statically sized array, but now the compiler is going to be able to look at this and be like, whoa, there's 6 elements. So the size of this array must be 6. So it's fairly smart. It can count. Now you can still leave that 6 there, and if you compile, it's not gonna gripe at you. But the thing is, if you go in here and add stuff, well, that's not really good because you're only allocating a size 6. And you can see you get a warning. So definitely make sure, if you can, just leave that number out. But it is always good to have a variable to contain the size anyways, because when we're passing arrays to functions, you have to have that size attached as another argument. So in this case, we got 1, 2, 3, 4, 5, 6, 7, 8 elements. So we might say size is equal to 8. And then you might do something like call a function, print array, just as an example. And you might pass in ages and the size. Without that size, it's not going to work out so well. And we talked about that in the previous video, so be sure to check that out. Okay, so one of the other things we talked about in the previous video is how to print an array. And I just wanted to make sure that was here just for completeness of this video. So we could say int I is equal to 0. As long as I is less than the size, we want to keep running this loop. And each time we want to increment that iterator by 1, and then we can print that element. Just like so. So let's compile and run, and you can see it prints out every single element all the way up to 21. You can actually change the value of these array elements just like you would any other integer. So you could say ages of 3 is, let's say, 60. And if we print this again, and also let's just print a new line here. All right, let's save and compile. The first time we print it, this value is 43. The next time it becomes 60. And the index is 3, so it goes 0, 1, 2, 3, 60. There you go. So that is how you work with arrays. The next thing I wanted to talk about is multi-dimensional arrays, which is a little bit more complicated. For that, I'm going to make 2 variables. I'm going to have int rows. So this is kind of like keeping sense of the sizes, but instead of naming them size, we're going to have it columns and rows just for clarity. Then we can make a multi-dimensional array like so. Student grades. And we put 2 square brackets. And you actually need to put the columns here just for it to work. Otherwise, it gives you a funky error. And then you can put numerous arrays inside of this initialization. So I like to just kind of build the shell first so I don't forget anything. So each one of these is a row. So you could do 1, 3, 4, 6, 3, 2, 4, 5, and so forth. Okay, so now we have 3 rows, 1, 2, 3, and each one of these is a column. So we got 1, 3, 2, 1, 3, 32, 3, 2, 2, 4, 4, 4, and 6, 5, 9. So we have 4 columns. So that is how you create a multi-dimensional array. Let's just compile, make sure I got all my syntax right. Okay, so we actually have to make this const in order for this to work. There we go. Now let's print this. So to do that, we need a for loop inside of a for loop. And where you put this here doesn't really matter. It's up to you. If you would prefer to have it back here, that's totally fine with me. So this one is going to print the rows, and then for each row, we're going to print each number, which is the columns. So we say I is less than rows, I plus plus. And then inside of here, we're going to say int j is equal to 0, and we're going to make it less than the columns, j plus plus. Then we just print the value. And what we're going to do is we're going to print student grades. The first box is going to be the row, which is I, and the second box is going to be the column, which is j. And then we'll probably want to do some formatting here. So let's say %d space, like so. And then let's say after each row, we just want to print a new line. So this inner for loop is going to print an entire row, and we're going to do that for every single row in this thing using the outer for loop. So it's going to go this one, and then this one, and then this one. All right, let's compile and run. And you can see it prints out the values just fine. That is the basics of arrays. The main things you guys need to know is how to create arrays and how to create multidimensional arrays, and how to print out all of the values. And not necessarily printing them, I just choose to print them. You just need to know how to reference each one of these elements in some order. So that's usually done with nested for loops. So thank you guys. Please be sure to check out the next video where we're gonna be talking about strings. Welcome back everybody. This video we're gonna be talking about strings. Now a string in C is just a character array. So you can make one like this. And then inside of these square brackets, you give the size of the array. And the important thing to know here is that you need to reserve one character for the \0, which is known as the Null Terminator. So what this is, and this is put in there automatically if you assign a string to this. I'll show you guys that in just in a minute. But what this is the Null Terminator, and it's basically a way to indicate the end of the string. So let's say you put the name Caleb in here. The characters are going to be C-A-L-E-B, Null Terminator. So that way, when we write programs that go through a string, we're able to tell where the string stops. Now the important thing is that you don't want to overwrite this character, because then our code could go beyond the end of the string and go into areas of memory we're not supposed to access, and then bad things are going to happen. Like your computer can explode, your bank account's going to get hacked, etc. So you don't want to do that. All right, so now the first thing we're going to do is scan a value from the user, and the conversion is going to be S for string. And we can actually limit the number of characters by passing in a number right here. So we could say 19. So that's going to give one spot for the null terminating character. And that is exactly what we need. So then we just store it in name. Now we don't need to use the address of operator, which looks like this, because when we pass an array to a function, it's automatically going to be converted, or technical term is it's going to decay to a pointer. So you don't need that. All right, the next thing we're going to do is we're basically going to write code to calculate the length of the string. And the way we're going to do this is we're going to go through each character and look at it and see if it's the null character. If it is, we're going to stop. If it isn't, we're going to basically increment a counter. So we're going to start a counter at 0, and we're just going to loop through the string. So because this is, in my mind, I use a while loop because this is an indefinite kind of thing. We don't know how long we're going to go. It makes more sense to me in my brain to use a while loop. So then what we do is we access the character. So letter starting at 0, we're going to grab the first character, then we're going to go to the second character, and we're going to keep doing that as long as the character is not the null character. And then what we're going to do is we're going to increment the counter every time that it's not the null character. At the end, we should be able to print the size. Just like that. I'm going to put a prompt in here so the user knows what to do. And then now let's just run and just see how the program would work. What is your name? Caleb, size of name is 5. Awesome. So there's actually some functions that'll do this for you. So in order to use these, you need to include string.h, and then everything should work just fine. So the first thing is that there's a string length function that will basically do all the work we just did, but I'll make it a lot easier. So we can say the same thing, size of name is, and then what we're going to pass in here is the string length of name. So the function is strlen, and then in parentheses we pass the variable that we want to calculate the string length of. So let's see if this works. All right, we do get a warning, and basically it wants us to use LU because it's an unsigned long different data type. So we can just go in here and change that D to an LU, and it should work just fine. What is your name? Caleb. Size of name is 5, size of name is 5. So basically what I'm telling you here is you don't need to reinvent the wheel. Some of this stuff already exists. Awesome. So what else do I want to show you guys? Well, there's actually a compare function. So if you have 2 strings, or if you have 1 string and you want to compare it to a certain value, like guessing a secret passcode or something like that, I don't know, you can do that pretty easily. And the way you do that is you use the strcomp for string compare. And you're going to pass in 2 things here. The first one is going to be the variable, and then the next thing is what you're comparing it against. So Caleb. And then you need to do this. You need to say equal 0. It's kind of odd here, but if these are equal, this string compare returns 0, which this entire thing will evaluate to true. So hopefully that makes good sense. And if it doesn't, just know that you need to put equal 0. So now you have to guess the secret name. If I put Caleb, you get access. But if I put something else, we'll see if it works. If I put tacos, it's my code name, we get nothing. The next thing I wanted to show you guys is how we can copy a string. So for example, if you wanted to copy the value from name into another variable, you might think to do this, which is not going to work, by the way. So you could say, oh, I'm going to create another one, give it a size 20, and set that equal to name. You can't do this in C. You actually have to use a function for this. So you can declare that variable like this, but then the function you want to use is called strcopy with no vowels. And then you put the copy here, and then what you want to copy from in the second argument. So the destination comes first, and then where you're getting it from is second. We should be able to print the value of copy. And we're going to use %s because it's a string, and then we're going to pass in copy. What is your name? Caleb. Copy of name is Caleb. So that's how you make a copy of a string, which might come in useful. The last thing I want to show you guys is how to do string concatenation in C. So in order to do that, let's say we have a variable last name, and we're going to set this equal to Curry. And like I said, you don't need to put a size when you're assigning directly, so this should work. And what the code is doing here is we're going to basically append to this copy here, and what we're going to append to it is the last name Curry. So then when we print it, it should come out as Caleb Curry, which is my name, in case you guys didn't know. Okay, I got an issue. I need to put a semicolon. What is your name? Caleb. Full name, Caleb Curry. Awesome. So those are just some basic string functions. I'm sure you could make some custom string functions and make a pretty sweet library. In the upcoming videos, we're going to be talking about creating our own functions and how to put those in a library and do multi-file compilation. So we got a lot of cool stuff coming up. Let me know if you guys like this video and if you have any questions at all. Thank you, and I will see you in the next one. Hey, what is up, everyone? This video, we're going to be talking about functions and how to create our own functions. Now, what exactly is a function? Well, a function is just a section of code that you can basically assign a name to it and give it an input, and it'll give you an output, or it'll do something for you. And you don't have to keep writing the same code over and over again. You can just call that function. So we're actually inside of a function main, and all of our code goes inside a main, but we can create other functions. So we're going to start off just going through various examples of functions, and they're going to start off very simple to where they almost seem kind of pointless. But once you get into more complex functions, it makes a lot more sense to use functions versus the code inside of the functions. And you'll see what I mean. So let's just get started. Let's say we wanted to create a function that will square a value. So the easiest way to square a value is if you have a value like x, all you have to do is say x multiplied equal x. And when you print that, and compile and run, you'll get 25. So squaring a value, it's just the number multiplied by itself. You could also do equals x multiplied by x, same thing. Now, if we wanted to extract this functionality into a function, what we would do is go outside of main. So go up here, and we would say, hey, what type of data are we trying to get? Well, we're going to get an integer. And then we give it a name, which we can call it square, as an example. And then you give parentheses, and then a code body. Inside of the parentheses is where you make parameters. And parameters are going to store the data passed into this function as arguments. So we're going to have basically an input variable. And this value is going to come from main. So you would call this like square, and then you would pass in x. And that's going to return an integer. So you would store it in something. Like so. All right. Then we can actually print x squared. So just take a couple minutes to digest all of this. If you're new to functions, it can be some more syntax you have to become familiar with, or ways of doing things. But basically, now what we're doing is we are just calling this function, and it's going to calculate the square of this input. This when you pass in the data, it's known as an argument. Inside of the function, where it's stored, is called a parameter. So it's going to calculate the square of this parameter inside of this and return that value, which is going to be stored in x squared. So inside of the function, you could say input times input, and then all you have to do right before it is say return. And that should work. So let's compile. And you can see we still get the same value, 25. Now, this is where it's kind of like, oh, what's really the point of that? Why don't we just keep it how we used to have it? Which you can in this situation, but as you get more complex functions, it's a lot easier to do something like this than to take all of the code inside of the function and continually repeat it throughout your program. It's based off of the principle of only doing things one time, or the dry principle, don't repeat yourself. And it will allow you to execute the same functionality numerous times by just calling the name of the function and not having to repeat yourself by putting the same code. Because if you wanted to later go change an algorithm, or you found a bug, you might have to go throughout your entire program and change every time you use those lines of code. If you have a function, you only have to change it in one place, and anywhere calling that function is automatically going to use that new code. So that is why you should use functions. But obviously this is a very simple example, so I want to go into a more complex example. Let's say we wanted to make one you can basically create multiple functions and build a library. So you can do multiple things by just calling various functions. So you could have one such as cube, and it's still going to take an input. And in this body, it's going to basically do the same thing, but it's going to do it 3 times. And return. So this is basically another function in our library. Alternatively, you can create local variables. So basically variables that only exist inside of this function. So I could say int x, and we could set that equal to the value that's calculated. And then we could return x. That works exactly the same way. And when you go outside of this function cube, this variable no longer exists. So this x here is different than this x here, just so you guys are super clear. That has to do with variable scope. Anytime you declare a variable, it only exists inside of the curly braces that it's defined in. That goes for all things. So even if you did an if statement, if you declared a variable in here, well, outside of this if statement, it's not going to exist. All right, so that's really not that complicated either. Let's try to make a more complicated one. Let's say we wanted to create a function to, instead of having a function to square something, a function to cube something, let's just make a more general one that can raise any number to a power of any input. So it looks something like this. So we're going to need the input, just like always, but then we're going to have another input, and we could call it exponent. Names don't matter, it's just for your use here. And what we're going to do in here is we could actually basically go through this, multiply input by itself exponent number of times. All right, so we could do basically, there's numerous ways you could do this. What I'm going to do is I'm going to basically have a total number that's just going to keep track of everything, set that equal to 1, and then I'm just going to do a for loop to basically multiply 1 by input until we do it exponent times. Hopefully that makes some sense. If not, just watch. Okay, so if we passed in the value 4 for exponent, this is basically going to go in here and it's going to multiply 1 by 4, which will give you the value 4, and then again by 4, again by 4, and again by 4. So you'll end up getting the correct value. At the end, you just need to make sure that you use the return keyword to give the value back to the caller. And then inside of main, we could call that function. So we could say, I don't know, we can just make up some variable, x to 5. We could say int, yeah, we need to declare it. So int x to 5, and we could say, hey, we need to call power, and we're going to pass in x, and we're going to raise it to the 5th power. Then what we need to do is we need to print that out. Like so. Awesome. So if you take 5, raise it to the 5th power, you should get this number here. So now we're making our functions a little bit more useful. They don't just do one thing, but you're able to change the functionality by changing the inputs, like so. And this can also replace that squared and cubed function because we could just pass in 2 or 3 here. And also the squared. So there you go. You can see that this function here, power, has much more use than these functions up here. So you could, if you wanted, you could get rid of these and just use that power function. So the next thing I wanted to do is a recursive function. And recursion is outside of the scope of this course. And if you've never used recursion, this is going to look like some black magic, I tell you. But if you have used recursion, hopefully this would be a good example of what you could do. So we could basically create this same function using recursion. And recursion is when a function calls itself. So I'm just going to give it the name recursive power, and it's going to do the same exact thing. In fact, it's also going to take an input and an exponent. But the way we calculate this is fundamentally different. Basically what we want to do is we want to have the input and multiply that, and then we need to call the function itself with a subset of the input. So what we would do is say recursive power, pass in input and exponent minus 1. And then we're going to return this. So let me explain how this works. If you think of input being the value 5, when this function's hit, it's going to return 5 multiplied by something. And this something is going to start at the beginning, which is going to return input 5. And it's going to keep doing that, and eventually it's going to stop when it hits what's known as the base case. So we could say if exponent is less than 1, we're just going to return 1, which will just multiply it by 1, keep the original value. So this is basically just going to multiply it by 5 for every value of the exponent, and each time the exponent number is going to go down until it hits 1 or 0. Once it hits 0, it's just going to multiply everything by 1, which keeps it the same, and we should get that same value. So hopefully that made a little bit some more sense than it sounded like it made sense in my brain. So then we could say recursive power, pass in 5, raise it to the 5th power. Awesome. Let's try it. Okay, we have an issue. Okay, I forgot to get rid of the references to these square functions, so I'm just going to get rid of this one here, as well as this here. Awesome. And it printed the value of what the original power function did when we passed in 5, so it seems to be working just fine. One thing I wanted to mention to you guys is that when you pass a variable into a function, it's creating a copy of that value, so you can't change the original inside of the function. And just to see that, let's say we have a function, and by the way, we're going to talk about void functions. Void functions are not required to return a value. So we could say change val, and we could take an input, and let's just say input is equal to some number. Okay, then in here, let's say we call this and pass in x, and then after it, we print x. So if you could change the value, you would think that, hey, we pass in x, inside of here, it gets changed to 900,000, and then we print it, and it prints 900,000. But the reality is, the value of x is copied into this new variable input. So the local variable input is changed, but x is never changed. So when we run this, it should print the value 5. And you can see it does. Now you can change the value of a variable passed in, but you have to make one small change because it's not going to do this by default. And that is, instead of using a normal variable like this, we're actually going to use a pointer. And we're going to be talking about pointers here soon, but just follow the syntax for right now. In the parameter, you're going to put an asterisk right before the identifier of the variable. And then when you need to change the value of it, you're going to use an asterisk. And when you pass it in, you're going to use the ampersand address of operator. Now when we compile, we should get the value 900,000. So x itself is changed. And that's because when you pass in a pointer, we're able to change the value at that pointer. This is now pointing to the same data that this is pointing to. So hopefully that makes some basic sense. And once you get into pointers, you'll understand this a lot more, but this should give you a pretty good foundation. The next thing I wanted to talk about is functions that take arrays. So let's clear out our main and let's just get some space here. Let's just pretend we have a fresh start. And we're going to create a function that goes through an algorithm to get the largest value inside of an array. And let's just say we have an array, ages. And this is going to basically contain a list of all the ages of our friends and family. And we're going to create a function to get the largest value in here. So whenever we pass an array to a function, we have to have the size. So we can have a size variable here and set that equal to 7 because there's 7 elements in this array. And the way you could print this out would be something like this. And then you're going to call the function inside of the printf argument, which works just fine because this function is going to return a value, and then that value is going to be passed into printf. You don't always have to reassign it to a variable and then use that variable, although you can do that if that makes it easier to read. We're going to pass in ages, and then we're going to pass in the variable size. So that is how we call it, but now we need to define it. So it's going to be called oldest value. It's going to return an integer. It's going to take an int array. We're going to call it the same thing, which is allowed. And then it takes an int size. The way I like to do this algorithm is you just go through the entire list starting at the beginning and just keep track of which one's the largest. So we could say int largest equals, then we're going to get the value ages of 0, which is going to get the first element. So to begin, we're just going to assume that the first element is the largest. Then we're going to iterate through the entire array and just see if any of them are bigger. So for int I equals 0, I is less than size, I plus plus. And we can actually start at 1 because 0 is already gone through assigned to largest, so we need to only compare after that point. So inside here, we can just do a comparison. If ages of I is greater than largest, the largest is going to become ages of I. We're just going to replace the largest value. Then when we are done, we need to return the largest. All right, let's compile and see if this works. It prints 53, which is in fact the largest of the ages. So that is awesome. One thing you also need to remember is that you need to have a variable size, because anything done to calculate the size of an array inside of a function is not going to work when we're working with a passed in value. That's because this is really just a pointer. It decays to a pointer. Upcoming, we're going to be talking about some pointers and memory management and some of the more advanced stuff in C. So be sure to check that out, guys. Hopefully that gives you a pretty good crash course of functions. Obviously, we can't cover everything. The main thing you need to know is that arguments are the things passed in. Parameters are the variables created in the function declaration that store the data passed in. We have the return type here. We have the return statement, which returns that value. And then we also have void functions, which don't have to have a return. You can, if you want, use the return keyword in here, but you're not going to put anything like a value here. So that's basically it, guys. Hopefully that was helpful, and I will see you in the next video. Welcome back, everybody. This video is where we're going to get into some pretty cool stuff because we're going to be talking about multi-file compilation and how you can take the previous video content where we created all these functions, and we're going to turn that into a function library that we can include in our code. So that's pretty cool because then you can take a bunch of these functions and basically create a library that you could open source or give out to your employees or whatever you want to do with it. I don't know. Or if you just want to organize your program so you don't have a bunch of these functions, you can put them all in a different file. So yes, this is a little complicated when you start. Honestly, I usually just reference syntax just to make sure I got everything correctly, but it's really not too complicated. Plus, once you got it down, you can actually take all of the commands that you use to compile your multi-file program, and you can put them in what's known as a make file. We're not going to cover that in this video. If I create an intermediate C programming series, which I'm intending on doing at this point, I'm probably going to talk about make files there. But that's just a way, once you have all the commands, you can put it in one file and use that to do everything for you and just automate the process for you a bit. But that's really not what I wanted to talk about in this video. So let's get back to the point. So this is the same exact file from the previous video. The only difference is that I renamed it for the appropriate section. and then I indicated that it was the main. Now you can name it whatever you want. The only thing is you got to remember which one has the main function in it. Then the next thing you're going to do is you're going to create a new file. So I'm just going to call it 5.2 libraries for the section title. And then I'm just going to leave it at that, .c. Okay, and what I'm going to do is I'm going to take all the functions we created in the previous video, cut those, and paste them in the libraries.c. Cool, so that's step one. Step two is I'm going to create another folder, and I'm going to call it 5.2/libraries.h for a header file. So when you include things, if you go back to the main, you can see this include standard.io.h. Well, this header file, it's really just a list of all of the function declarations, what input types they need, and what the return type is. So we're going to create a similar thing with our program. So what we're going to do is we need to copy all of these functions and paste them in here as well. But we're going to get rid of the bodies. So yeah. Sounds like very morbid. Gotta get rid of the bodies. All right, delete all of these bodies and just have the signatures. All right, so this is our header file. And we're going to go back into this, but for now, this is good. So what we need to do now that we split these files into three, inside of the main program, we need to say include, and instead of using the lesser sign, we're going to use quotes, which will search in the same directory for this header file. And we're going to say the name of it, which is 5.2 libraries.h. Cool. We're going to take this include, and we're going to put that at the top of the C file as well. The one without main in it, the one that has all the function definitions in here. Cool, so that should be good, but just as a protection kind of thing, inside of this libraries file, we're going to put a condition that says, hey, if you've already tried to include this, we don't want to include it again, just so we don't re-declare this header file. And that's going to look like this. It's kind of funky, but if ndef header file. So if it's not defined, we're going to define it. And then at the end of it, we're going to say end if. So yeah, the compiler can use these commands to better understand what we're trying to do. All right, so we should be good. Now all we need to do is we need to learn how to compile these things. So this part is a little bit more of a process than we're used to. So we're going to take the C files and we're going to compile those. And then we're going to take the output of that called object files, and we're going to link those together using the linker. All right, so what we're going to do is we're going to say gcc-c 5.2 libraries.c. So that's the first file. And when we compile this, we're going to get an error. Oh, that's because I was dorking around earlier. Okay, I need to fix that. Get rid of that. That shouldn't have been in there anyways. All right, let's try this again. All right, so we compile, and what happens is we get this new .o file. So this is an object file. It's the compiled version of this code. All right, so the next step that we need to do is gcc-c 5.2 libraries -main. So now we're compiling our main program, and this will give us an O version of that. The next thing we need to do is we need to combine these into one executable using gcc, and then we just put the name of the object files. So we do 5.2 libraries main.o and 5.2 libraries.o. So that'll take this file and this file. Compile those. We didn't get any errors, so when we do a.out, you can see that the program is still executing and it still works, even though inside of our main program, we don't have those functions defined here. Another thing I wanted to mention to you guys is that these object files are like an intermediate step between compiling and the final product. where they're basically the compiled code, but you still have to put them together using linking. Now you can basically skip this process to where you don't want to make this output file, you just want to go straight, and that would look basically like this. So you get the main file.c, you compile that, as well as the one without the main, which just has the function code. So 5.2 libraries.c. And you can see that will give us the correct output. So these are only kind of beneficial if you want to give the code out as a library, but you don't want to have the source code there. You just want to have the compiled version there. And then the header file acts as like the interface to work with that file. So you go into the header file and you see, oh, this will take an input and an exponent and it will return an integer. So you should basically know how to use it. And you can also put all your comments in here for more instructions. So that is the entire process for creating multiple file compilation. Quite the process, as you can see, but once you do it a couple times, it's not too terrible. You just got to remember all those steps. Fortunately, in the syntax reference, I'll have all the notes for how to compile those, and you can use that just so you know what to do for the headers and so forth. All right, so that's all I got for you guys. Thank you, and please be sure to check out the next video because this is where we're going to go into some of the more intermediate stuff of pointers, structs, and memory. So it's going to be sweet. See you guys there. Hey, what's up guys? Welcome back. This video is going to start talking about pointers. And my dog's bugging me. Hi, Cotty. Hey there. Would you like to help point these people in the right direction? See what I did there? So the way you create a pointer is, well, first, let's say we have a variable a, and we're just going to set it equal to 100. Now, what we can do is we can make a pointer to this variable using the address of operator. So that is the ampersand 7, capital 7. That is a pointer to a. But you don't just want to leave it out there, you actually want to assign it to something. So in order to assign it to something, you create a pointer by giving it the type. It's going to point to an integer, and then you use an asterisk and then the name of the pointer. So our pointer is named B, and it points to A. So now B stores the location of A. So that means we can basically alter the value of A by going through A directly. So we could say A is 200, or we could go through the pointer indirectly, and you'll be seeing that in just a moment. So I'm going to go through some examples. So to do that, I'm just going to print A and the value at B just to show you guys that they're connected. We're going to copy this and we're going to change it to B. But we're not going to just print B by itself like B. We're going to use the asterisk B. This is known as the indirection operator. You may also hear dereferencing a pointer. So when people are saying dereferencing a pointer, they're just saying, hey, give me the value that the pointer points to. So hopefully that makes good sense. You'll understand though once we go through some examples. The important thing to know here is that when you declare a pointer, you use the asterisk. And then when you get the value at the pointer's destination, you use the asterisk. But these two things mean two different things. Up here it means we're creating a pointer, up here means we're dereferencing a pointer. That's one of the most confusing things, and that really got me confused when I first started. So let's print this and see what happens. All right, cool. So they both give us the value 100. And the cool thing is that this is the same value in memory. So that means if we go in here and we change A to 200, these are both going to spit out 200. So I'm going to print these both again. So the first time they both equal 100, we change the value of A, they both equal 200. All right, so now we can do the same thing by going through the pointer using the indirection operator. So we can say the value that B points to is now set to 300. Print these again. And you can see that both B and A change. So you can see they are the exact same value. It's just we're able to use two different variables to change and use that value. The other thing I wanted to talk about is that you can change the value that the pointer points to, or you can change the value of b itself. So for example, if I made another variable, and what I could do is I could change b to point to the address of c. So now b no longer points to a, it points to c. So the main thing you need to understand is that there's a difference between b and the value that b points to. There's a clear distinction. B itself is just an address of memory. The value that b points to is an integer, in this case the same one that is stored in C, 6,000. So now if we went and changed a, and then we printed them both out again, well, now they should not be the same thing. And they're not. That's because b no longer points to a, it points to c. So we could update c, and we would see this changes reflected when we were referencing the value at b. So to show you some of the cool things we can do with pointers, the first thing is you can change the value of parameters inside of functions. So for example, we created a square function in the earlier video that would basically just take a variable, square it, but we had to take that value and store it back into something, either replacing the original variable value or creating a new variable. So what it ended up looking like is int x equals 5, and then you could say x is the square of x. And obviously this is a very simple function, but the concept stays the same. But what if we just wanted to say square x and that's it, and we didn't want to have to reassign that to something? Well, you can do that with pointers. So instead of passing x, we can pass the address of x using the address of operator, and now we're passing a pointer into square. Then when we declare square, we can make it a void function because we don't actually have to return a value, because all we're doing is changing the input rather than creating a new output. So the input is going to be an int pointer, so we can just call it input. And then inside of here, we could change the value of input. And to change the value, you always have to dereference it using the asterisk. So we could say input, and we could just multiply that by the same value. So this should square it, and it's going to change this, so no return. All right, let's compile this, see if it works. Make sure I save it. Okay, I didn't print it, so obviously I'm not going to know. All right, let's try now. And it prints 25. So you can see it works. That is the power of pointers. It allows us to change the value of variables inside of functions. The other thing is that if we're working with arrays, pointers are going to come in because when you pass an array to a function, it decays to a pointer. And I've talked about that, I've mentioned that throughout this, but I never really explained it or went through any examples. So now I'm finally going to do that. So let's just create an array of ages. And like I said, you always keep track of a size. So we could say int size is equal to 1, 2, 3, 4, 5, 6, like that. So we're going to pass that size in any function we end up using. So just to show you that this actually does decay to a pointer and what exactly that means, it means that when we pass it to a function, the identifier ages is no longer considered an array, it's considered a pointer. So we can see this by using the size of function. So just looking at the memory size of it. Memory size of ages, it's gonna be %LU. Just like that. So let's run that. I need to put a semicolon. All right, so the memory size of ages is 24. And that's because each integer takes up 4 bytes. Now, if we call a function, let's just say size example, it really doesn't matter, and we pass in ages, let's go create this function. In here, we can, we have to take it as an argument, so we can say it's an int array, and we're going to print the same exact thing. So let me just copy it from down here. Awesome. And it says it will return the size of an int pointer instead of int array. So even the compiler is telling us that, but just in case you did want to see what would happen when we run this, you can see that the memory size becomes 8, which is the size of a pointer. So whenever we create a function, like if we create a function to print an array, you're going to want to include that size, which in this case is 6. Okay, so that kind of sums up the use of pointers. There's really only 3 things you need to know. The first is how to create a pointer, use the address of operator, how to declare a pointer using this syntax here, and then how to dereference a pointer by using the asterisk followed by the identifier name. So those are the main things. Pointers are used to change the values of arguments inside of functions, and once we get into memory management, they're going to be used as well. So check out the upcoming videos, guys. It's going to be a lot of fun. Thank you, guys. I'll see you then. Welcome back, everybody. This video, we're going to be talking about structs. And let me tell you, structs are one of my favorite things in C programming. They're really super cool. They basically allow us to encapsulate numerous pieces of data or values inside of one variable. So to go through an example, let's say we wanted to create a rectangle or something. Well, we might have a length and we might have a width. And that's not too crazy, but if you had numerous rectangles, you'd have to have 2 variables for every single rectangle. And that's just a very simple thing we're trying to create. What if we had a more complex structure, and as a result, we just had numerous variables we had to keep track of? Well, with a struct, we could basically combine these into one data type called rectangle, for example. So to do that, what we need to do is outside of main, we can say struct rectangle, give it a name, and then inside of these curly braces, put these 2 variables. So that is the simplest way to make a struct. So now, when we create a variable, instead of saying int length or int width, what we do is we say the type is actually rectangle, and then we give it a name, my rectangle, whatever you want to call it. And before the rectangle type, we actually have to say struct. So this is how we declare a struct. And we can give it values by setting it equal to, and then using curly braces and putting 2 values in here. So we could say 5 and 10. So it's basically a way to group a length and a width together inside of one variable, my rectangle. Okay, so how do we actually go and access the values? Well, if we wanted to say print these, for example, well, we could say the length is equal to, and the width is %d, and the value we're going to pass in is my rectangle dot length. And that's for the first one, and then we're going to pass in my rectangle dot width. So this dot operator allows us to access the members of this variable, my rectangle, which correlate to the length and the width. Now the only thing that's different about creating one of these things is this struct keyword. Now there's actually a way to get around this, and to do that, it's a little funky, but you have to put type def, and then down here you say rectangle. So that is how you would get rid of this requirement to put this struct here. It basically allows us to use this rectangle as any other data type. And then this variable here, this value here, is actually optional. You could get rid of that if you wanted to. So this is a good start, but we can actually make more complicated things. So for example, let's say we created another struct for a position. So we would say type def struct position, and this would have an int x and an int y. Now together, these things are kind of useless by themselves. So a position is just a location and a rectangle is just a rectangle. But if you combined them, maybe it could be something like the building plans for a house. So this is the size of the house and this is the location of the house, for example. So what you could actually do is you can make a struct of these other structs. So we could say type def struct building plan. And inside of here, we could have the first one be the rectangle. And you can actually name this the same thing as the type. So we could say rectangle, rectangle, and then position, position, just like that. We could also store other things in here. For example, we could have an owner. So this could be a string, like so. And that's where we could store the name of the owner. So we can start building more complex structures using structs. If we wanted to create a building plan down here, it would look like this. We would give it the type building plan, give it a name, and then inside of these curly braces, we could just assign a value for each one of the things. Caleb Curry for the owner, and then for the rectangle, we're actually going to use another set of curly braces, and we could say this is at a 10 by 5 house, or let's go 5 by 10 just to be consistent with this here. And this is at position 3248, which I know means absolutely nothing here, but just follow along. Pretend these are some kind of coordinates of some sort. And we can actually print out this entire house, and we only have to use this my house variable rather than keeping variables for all of this information. So I'm going to write out a printf statement. It's going to be a little bit more complex than usual, so I'm just going to skip to when it's done. All right, so here's the format string. The house at position, size is owned by name. Then we just have to make a list of all the arguments also passed in for these formats. All right, so this is the entire printf statement. You can see we can traverse through these structs using the dot operator. So we can say dot position, and then inside of that, dot x. All right, so let's compile and see what happens when we print this. All right, I have an issue. All right, I have a spelling mistake in position. So I'm gonna scroll up and fix that. There we go. I also have a spelling mistake here because I can't type. I also forgot to put the type here because I'm a failure, apparently. Okay, hopefully that was everything. All right, finally, let's run the thing. The house at 3248, size 510, is owned by Caleb Curry. Awesome. So that shows how to use structs in your program. The next thing I wanted to show is that you can actually make an array of structs. So for example, if we wanted to make an array to store a bunch of positions, for example, it could be a path. We could say path and set that equal to numerous positions. So inside here, each one's going to be inside of curly braces. And we could say where you need to go for this path. So what each point is. We could then iterate through this entire array with a for loop. Typically, if I'm going to use a number here, I like to assign it to a variable. And then we can basically print these values. Like so. Obviously, you don't want to return beforehand. You want to do that after. I always forget to do that for some reason. All right, so there it'll print out the path. Awesome. Another thing I wanted to talk about is how to make a pointer to a struct. It's fairly simple. So if we have a struct, so scroll up, we have this my house, this is a struct. Well, we can make a pointer to that, just like we would make any other pointer. We use the asterisk symbol and then give it a name, just like so. And then we can set that equal to the address of my house. Okay, so when you want to access the values at this pointer, it's a little bit different. So typically you use this dot operator, such as right here, but now you're going to use an arrow. So you could say struct pointer arrow, and then you would be able to go through here and say position or rectangle or owner. So let's just say position.x, and let's print this. And you can see there, it prints 32, which if we scroll up, we can see that we did define it as 32. So those are how to do the main things with structs. Inside of the syntax reference, there's some more details if you need them, such as how to pass structs to functions, how to return them from functions, how to create structs with pointers in them, and just stuff like that. So please be sure to check that out if you need more practice with structs. But more than likely, this gentle introduction will be enough just so you understand the concepts and can start building your own. So thank you guys for watching. Please be sure to check out the last video, which is the next one, the last instructional video, which is going to be talking about memory, which is another really important part of C programming. So don't miss out on that one. Thank you guys. I'll see you then. Welcome back, everybody. In this video, we are going to be talking about memory management inside of C. And specifically, we're going to be going into dynamic memory allocation, which is a really important thing to know. So hopefully by the end of this video, you have a pretty good understanding of the basics and you can use dynamic memory effectively. All right, so the very first thing is this concept of memory is very closely tied to variable scope. And we've talked about it a little bit throughout the series, but I never had a dedicated video to it. But basically, if you declare a variable here, such as this, well, it only exists within these curly braces. So if we had a function up here, we'll just call it fun, and we said, hey, we're going to increment x. This isn't going to work. And you see we get an error because this x doesn't exist inside of this function. It only exists inside of this main function. The same thing goes if we do something like this, an if statement, and let's just say true, and we create a variable in here in y equals 10. Well, if we said, hey, we're going to increment y out here, and let me get rid of this error just so that doesn't come up again. The same thing happens because y is only in existence inside of this code block. So what does this have to do with memory management? Well, essentially, these variables will die and go away at the end of the scope that they're declared in. This is the way we've been creating variables, and we haven't really talked much about different types of variables. So one other way of creating variables is statically. So for example, I could declare a variable static in here. So I could say int static x equals 0. And what I could do then is increment x. And just follow with me for a second. What I'm going to do is I'm going to call the fun function numerous times. And at the end of this fun function, I'm going to print it. All right, let's compile and run. So you see it gives you 1, 2, 3, which is interesting because at the beginning of this function, it's assigned the value 0. So how is it keeping the value? It's kind of odd, right? The reason this is happening is because when we create a static variable, we are creating a variable that exists for the lifetime of the program. Now, that doesn't mean it's available everywhere. For example, if we tried to access x out here, it's not going to work. We still get the error. So the scope stays the same, but the lifetime of the variable now persists, and it only gets initialized one time to 0. So that is the second type of memory management. The first one was automatically, the second one is statically. And this video is going to be about that third one, which is dynamically. With dynamic memory, we are in charge. We ask for memory, and when we're done, we give it back. So it's a little bit more work, but it's overall not too complicated. Another benefit of dynamic memory is that the content in this memory is accessible anywhere as long as we have the address to this memory. So that means we can basically create something inside of this function and we can access it inside of this main function, even though typically that's not possible. If I was to say, hey, we have this variable int u, well, we wouldn't be able to do something like u++ down here in main, as I showed you guys earlier. But with dynamic memory, that becomes possible because the area of memory is going to stay allocated until we manually free it. So it takes a little bit more work, but it definitely gives us more capabilities, especially if we want to create dynamic things, such as an array where we can change the maximum number of elements. Those kinds of things are possible with dynamic memory. Now, what I'm going to do is I'm going to clean up all this crap because we have a bunch of junk floating around in here. And I'm going to clear this. All right, so we're just going to have a fresh state. So if we create an array, we have to statically size the thing, meaning the size is determined at compile time and we can't change it. So it looks something like this. And in this situation, we either have to know how many elements are up front right here and hard code them, or if we're going to get the elements from a user, we just have to put a hard cap and say, hey dude, you can't put anything more than 50 elements in. At that point, you're done. Both of those are not really useful because the first one, typically we're not going to be hard coding values into an array. Most of the time we're going to get that data from a database or from a user input. The other way of just giving a huge number, the thing with that is that if the person only ends up using a fraction of that, we're wasting a lot of memory. And the other thing is if they wanted to use more than that, they can't. So what we're going to be doing is we're going to be creating a dynamically sized array by asking the user, hey dude, how many elements do you think you're going to need? So let's just get rid of this array. We're not going to need it. What we're going to do is we're going to create an integer size, and we're going to get that from the user. So let's ask them how many elements they need. And then we can scan a value into size, just like that. Now the way we allocate memory is calling a function called malloc for memory allocation. And then inside of here, it's going to take a size, how many bytes. The way you decide how much memory you need is you think of what you're going to be storing. Let's say we're going to be storing integers. Well, an integer is 4 bytes, and the person needs a certain amount. So what we could do is take 4 times the size. So how that's going to look is something like this. Size times, and you could either put 4 or you could put size of int like that. Either one is fine. So this is going to allocate the memory, but now we want to be able to reference that memory location. So this malloc function is actually going to return a pointer. So we can do int, and we can just call it whatever we want. Let's call it R for array. Okay, so we are basically making a pointer that we're going to be using as if it's an array. Let's just make sure we don't have any compiling errors yet. And we do. Let's check. Okay, I just got to put a semicolon. We good, we good. All right, all good. So now what we can do is we can actually ask the user for each one of the data points, and it'll keep asking them until they fill up all the elements that they need. So we can do that with a for loop. So we're going to go all the way from 0 to size, and we're just going to scan in a value as an integer. And we can actually store this inside of R as if it's an array. So we can use the address of operator because we have to use the address of operator with scanf because it needs a pointer. And then we can just use I. So yes, this array-like syntax does work for pointers. And that makes sense because when you pass an array to a function, it decays to a pointer, but you can still use array-like syntax. So at this point, it should ask the user for every single element, and then what we could do is we could actually go back and print those elements just to make sure it worked. So we're going to do this with another for loop. And we're just going to say R, and then we're going to say %d, and we're going to substitute I in for that, and we're going to say that is set to another %d. So the first one's going to be I, and then the next one's going to be R of I. Awesome. All right, so let's run this and see if it works. How many elements do you need, bro? Let's say we want 6. Now it's going to take all those elements. So you can say 3, 5, 7, 8, 4, 1. And then it prints all of those values. So it says 3, 5, 7, 8, 4, 1. Awesome. So we basically just created a dynamic array. Now here's the gotcha. When you do this, you have to remember to free the memory. Because if we just keep allocating memory, we're going to be wasting that memory. And we run at risk of either running out of memory or basically creating what's known as a memory leak, where we just keep creating memory and we're not freeing it. So we need to use the free function and pass in that variable, the pointer. All right, so that should be good. You're good to go. You can start using this dynamic array for all kinds of fun things. Now, when you do this memory allocation up here, it's going to return a pointer of type int. But there is a chance that it might return a null pointer. And what this means is that it wasn't able to give you a pointer because there's not enough memory to give. So in that situation, the value of that pointer would be 0. So you might want to check to see if the memory allocation was successful before you go and do everything with the supposed memory you've just gained, which you actually didn't. So to do that, before we free it, let's just try it. We can say, hey, if R is equal to 0, invalid pointer, error allocating memory. Else, you're good to go. Now, obviously, this is kind of a flawed example because we're using the array up here, which kind of defeats the purpose. But if you wanted to, you could put this at the top. So we could cut this, paste it here, and then say, hey, if this is the case, we're just going to return 0. Or you could even return -1, which means something went wrong. Okay, so let's compile and run. How many elements you need, bro? We could put in 3. And it said you're good to go. So now I can start putting in those values. There you go. Now we can go back down here and free the variable. You're free, go. I don't want you anymore. I never understood that in movies when like people are like, leave me, I love you, bye. It's not you, it's me. It's like, dude, if you love the person, why are you making them leave? Like, come on, grow up. Dynamic memory is very important if you want to create a variable inside of a function and make it exist outside of those blocks. So for example, let's go up to the top and create a struct. I'm going to get rid of this fun function. It's not very fun anymore. And we're going to create a user. And let's say they have a name, an age, and let's say they can verify their account. So we have a Boolean is verified, which means we're going to need to include standard bool.h. And lastly, I'm going to actually put this down here. There we go, it should be good to go. Now let's say we wanted to create a function, which is basically going to take these values and it's going to return a struct. Well, let's do that. Let's call it create user. And this is actually going to return a pointer to a user, like that. So this is the syntax when you want to return a pointer. And then inside of here, we're just going to take those values. So we're going to have a variable for name and age and bool is verified. All right, so what in the heck are we supposed to do in this code? Well, what we can do is we can allocate some memory, and then that's going to be a pointer to a user, which is why we're returning a user pointer. So let's say user and give it a variable name. So this is a pointer to a user, and then we can call malloc, and the size of this is going to be size of user. Then we can take the value of name and store that in the name of the struct. So we need to use the stir copy function, which is part of string.h. I think that's what it's called. Yeah, definitely what it's called. And then the first argument, as you guys learned and have remembered, of course, is the destination, new user. And we need to use the arrow because it's a pointer, which if you don't understand that, make sure you watch the video on pointers. When you have a pointer to a struct, you use an arrow instead of a dot. So we're going to store name into name, and the value we want to store there is name. All right, now we can set the other elements, the other members. Awesome. And then we need a semicolon right there. Okay, so let's call this. Inside a main, we might say create user. We're going to pass in the name Caleb Curry, age 72. Surprise, guys. And let's say this person is not verified. Okay, and then what we need to do is we need to store this in a pointer of type user. And we'll just call it me. Okay, so that should work. And now what we can do is we can use the variable me inside of this main function. So let's just print one of the data elements. We're gonna print age. Okay, let's try it. Figured I'd get some kind of warning. Okay, we need to return the user. just like that. How many elements do you need? 0. Caleb is 72 years old. Awesome. So that is how you can use memory management to your benefit. The one thing you got to remember though is you have to free the memory. So we could say free me. I'm free. And just to show you guys something cool, let me just print this and make sure it's still going good. Cool. So just to show you guys something cool which you can try on your own, you could say while true, and then you could just malloc, and you could just pass in some huge number in here and just run this. And you'll see that if you're not freeing the memory, your computer will quickly run out of memory. All right, that's all I got for you guys for this video. Please be sure to check out the syntax reference just for some clear reference material and some other good information that you might find useful. Thank you guys so much for watching this course. It's an honor that you've made it this far with my pathetic instruction skills and my boring attitude. But I really am thankful, and I'm hoping that the content of this course has given you what you need. Please, I just ask that if you have any feedback, let me know. You guys can help me make better content in the future, especially if I decide in a couple years to revamp this course. It would really be helpful to have a list of things that people found confusing or things people would want to know more about, and so forth. Additionally, I'm thinking about creating an intermediate C programming course, which is going to go into a lot more detail on some of this memory management and structs and make files and all kinds of other cool advanced topics. So let me know if that'd be something of interest to you, and if so, what kind of topics would you like me to talk about? Thank you guys, and I'll see you in the conclusion video. If there is one, I haven't decided if I'm going to do it or not. But if not, thank you guys. I'll see you. Welcome back, everybody. This video is just a conclusion to say thank you so much for watching this course. I wanted to say that it really means a lot to me, and if there is anything you have suggestions on, questions on, or things you would like for me to elaborate on in future videos or courses, please let me know. Your feedback is tremendously valuable to me, and I definitely want to hear what you guys have to think. I didn't want to leave you hanging with what to study next and where to go from here, so I put together just a couple of topics you could study on that would help you continue your studying in C programming as well as software development in general. So the first thing I'd recommend is take a look at some of the topics in this list. So for example, you can figure out more about data validation and input and output, so making sure people are submitting the correct stuff when you're asking them questions, how to connect to a database and work with data, and then going into some more complex data structures such as linked lists, stacks, queue, and so forth. And then I would recommend you just learn more about general software development principles such as source control, make files, deploying software to customers, software testing, and debugging. Obviously, this is a lot of information, and honestly, this course could be forever long, so I didn't want to talk about everything, and I just wanted to give you the essentials needed to get started. I am considering releasing an intermediate C course, so if that's something you'd be interested in, please let me know, and let me know what topics you'd like to see there. Thank you guys, and please stay in touch. Alright, I'll see you in the next one.
That is all for your C programming crash course. Let me know what you guys thought in the comments section below and what you'd like to see next. Oh, and don't forget to subscribe. Peace out.